It is helpful to understand how to compile and run Java programs without using an integrated development environment. For this section, we will use brackets as our text editor to write Java code and then compile and run the programs using the executables available from the Java Development Kit, or the JDK. All Java applications are compiled to bytecode that can run on any JVM or Java virtual machine regardless of the underlying computer architecture, making it platform independent. A Java application can accept any number of arguments from the command line. This allows the user to specify configuration information when the application is launched. To write and test programs using the command prompt, it is important to locate the folder where you downloaded the Java JDK. This is required to compile and run Java programs on your machine. When you installed the JDK along with your IDE, such as NetBeans, the default directory for Windows should look similar to this: C:\program files \java \JDK 1.8.0_31. We will use this information to set the path variables so we can compile and run our program from the command line. To open a command prompt, we go to the Windows icon and type CMD. Okay, now that we've reviewed the concept of command-level programming, let's dive in and get started with compiling and running our first program from the command prompt window. We'll start by creating a folder on our C drive to store our Java programs for this activity. Something to remember about the command prompt is that you can get a complete list of command-level options anytime by typing in the keyword help. In order to create a new folder, I can use the command md. Before I do that, I'm going to type in cls. This is a handy command to clear the screen. Okay, let's make a new directory, md space my Java. This is where I'll store the programs for this activity. Now that I created the folder, I need to change the directory to go into that folder, cd space my Java. Awesome. Now, let's write our first Java program in a text editor. I've already downloaded the Brackets application, which is a free text editor that you can download from the Brackets site. But you can use whatever editor that you're comfortable with. I've already maximized the screen to make it easier for us to see the code. I'll create a new file, File, New. But before entering the code, I'm going to save the file with a .java extension. That way, the text editor uses the correct indentation for my app. File, Save As, My Java, and we're going to call this demo.java. Notice the capital D in demo, lowercase emo. Remember, Java's case sensitive. And save. Here's the code that we need to enter into the text editor. We'll start with our class definition. Public class demo. Again, capital D, lowercase emo. It has to be the same name as the file name. Open curly brackets, hit enter. Now we'll declare our main method, public static void main. In parentheses, we'll identify the parameters string bracket for an array of string values called args. Open curly bracket for the main, and we're simply going to do system.out.println hello world. Chances are you've already written a hello world program at least once so far in your career. I know every time I learned a new language, the first program we created was hello world. Okay, let's end the main and end the class. Now I can save my program. Okay, let's go back to the command prompt. Before we can start compiling and running the program, we need to make sure that we specify the location of the Java virtual machine and the Java compiler to enable us to compile and run this program from within our My Java folder. In order to do that, we have to set the path variables as indicated. I already looked up the version of MyJDK, but make sure you do that prior to setting your path command. We'll type in set path equals $path $, Make sure you don't put any spaces before or after the equal sign. C:\program files \java \JDK 1.8.0_31, which is the version that I have on my machine, \bin, and then hit Enter. One thing to note is that you will need to reset the path every time you close and reopen your command prompt. If you want to, you can create a little batch file to do that for you. All right, we compiled the program using the Java-C executable. So let's type Java-C and the name of our program, demo.java. Again, make sure you use all the right upper and lower case, and you want to include the extension when you compile the program. The compiler compiles the program and creates a class file. A class file contains the bytecode for the program, and that's needed for the Java virtual machine. Once we have the class file, we can run the program using the JVM, or the Java Virtual Machine. So let's hit Enter to compile our program. Awesome! Let's check and make sure it created a class file. I'm going to use the command dir to see the elements inside this directory. We have demo.class and demo.java. Awesome! Okay, let's run the program. We type in Java space and the name of the class file. This time we do not use an extension. And right now, I don't have any default arguments being passed to the program, so that's all I need to do, and hit Enter. Hey, it says Hello World. Awesome, and there you have it. We wrote our program using a standard text editor, compiled and ran the program directly from the command prompt. Using the command prompt is not difficult, but it does require an understanding of file and folder structures. At the end of this section, there's a challenge, so make sure you give it a try. Have fun! In our demo program, we did not pass any arguments to the main method. There are times when the user needs to enter command line arguments when invoking the application. Let's create a new program to take in a message and then echo back each string on a separate line. In the text editor brackets, we will create a new program and call it demo-with-arguments.java and save it to our My Java folder on the C drive. I'm going to go ahead and save this program as demo-with-arguments.java. I'm going to navigate to my Java folder, and I'm going to click Save. We'll start by declaring the class, public class demo with arguments. Don't forget, this name has to be the exact same name as the file name. Okay, inside the class, I'll add my main method, public static void main. And in the parentheses for the main, I'll have the argument, an array of strings, and usually we give it the name args to represent arguments. The code for my main method is going to be fairly simple. I'm going to use an enhanced for loop to loop through all the values in the args array and then print them out. So for string s colon args, open curly bracket, system.out.println s. I'm going to close my for loop, close my main method, and end my class. Now I have my demo with arguments created. I'm going to save it. Now I can go over to the My Java folder in the command prompt. And the first thing I want to do is run that batch file we created to make sure the path is set. So I'll type in set path.bat. Okay, now I know the path is set. Now I can go ahead and compile my program. I type in Java-C because the first thing I need to do is compile it. I give it the name demo-with-arguments.java. Don't forget the .java extension here. I hit Enter. And again, if I don't get any errors, I know I'm doing good. Now I can run it. So let's run it with the Java virtual machine. You type in the word Java space demo with arguments space. No extension, but now I need to give it my argument. And my argument is going to be welcome to lynda.com. I'm going to hit Enter, and you can see my program printed out each of the words on a separate line. Welcome to lynda.com. So when the application was launched, the runtime system passed the command line arguments to the application's main method via an array of strings. Now let's consider the situation where the program needs to read in a number instead of a string. Because the argument value is in an array of strings, we need to parse the value, which converts the string to a numeric value. In brackets, let's create another program to convert a command line argument to an integer. File New, I'm going to call this public class num conversion. I'm going to go ahead and save this out to my folder. Save as, my C drive, my Java, and I'm going to call it num conversion.java. Okay, inside the class, the next thing I need to do is add my public static void main string bracket bracket args. And inside the main, the first thing I'm going to do is declare an integer variable called first arg to represent the first argument. I'm going to give it a default value of 0. Now, I want to check and make sure that the user did pass an argument, so I'll check the length of my args array. If the length is greater than 0, then I know the user typed in an argument. Now, I'm going to add a try and catch to make sure that the user typed in a number and not a string. Don't be concerned if you don't recognize the try-catch portion of this program. This is error handling code that is included later in the course. And what I want to try is, I want to try to assign first arg to the first element in the args array. But don't forget, I'm expecting an integer. So I'm going to type integer dot parse int parentheses, and again, I want the first element, so I do args bracket 0 bracket close parentheses and a semicolon. That's all I need to do, so I'm going to close my try block, but now I want to add a catch statement. So if the user did not enter a number, this is what's going to happen. I'm going to catch the error, which will be a number format exception error. I type in the name of the exception, and I give it a variable name such as E. And then I'm going to print out an error message, system.error.println, and I'm going to say argument plus, and I want to print out whatever was in position 0 so the user can see what the problem was. And then I'm going to say must be an integer. And if I do encounter an error, I want to get out. So I'm going to do system.exit, and I'm going to give it a value of 1. That is the end of my catch statement. If I got through the try and catch without an error, I want to echo back out the number the user entered. So I'm going to type system.out.println. I'm going to put you entered, and I'll print out the first arg that they entered. And that is the end of my main, and that is the end of my class. Okay, I'm going to go ahead and save this. Before we actually run it, in this example, we used integer.parseInt to find the integer portion of the first argument, which will be located in the array at position 0. If the value entered by the user is not an integer, remember the parseInt method throws a number format exception error, which is why we have the try and catch logic in our program. If the value is valid, it's stored in the first arg variable and then printed back to the console. Let's try the new program both with a valid numeric argument and again with a string. Before I do that, I have to compile it. So in my Java, I'm going to type java c space num conversion.java. It looks like I don't have any syntax errors. Now I can try and run the program. I use the Java virtual machine, java space num conversion. Remember, I want to give it a value. Let's start by giving it a valid value of 1, 2, 3, 4, 5. It looks like it worked because it says you entered 1, 2, 3, 4, 5. Now let's see what happens if I run it again, but this time I forgot and I'm going to give it a string. I'm going to say hello. This time, my program caught the error and it says argument hello must be an integer. In this example, we were expecting the user to enter an integer, but the program can handle all types of numeric arguments by calling the parse method. Depending on the data type, the string can be parsed into a numeric object, such as integer, which is what we used in this program, double, float, etc. These objects are called wrapper classes. Every primitive data type has a corresponding wrapper class that can be used to create an object with the numerical value of the argument. We will talk more about the numeric wrapper classes later in the series. For the remainder of our programming examples, except for the debugging section, we will be using the NetBeans IDE. Let's look at our first challenge. In this challenge, you should use a text editor to write a Java program. I use brackets, but Notepad++ or even Notepad would work just fine. The program should take in a string prompt as an argument. Then it's going to print that back to the screen. The prompt message should ask the user to enter their name and their age. Use the scanner class to read in the name as a string and the age as an integer. Using this information, display the information back to the console. Once your program is written, make sure to save the program to your My Java folder on the C drive. Don't forget to set your environment variables before trying to compile the .java file. Go ahead and compile it using the command line, javac space your program name .java. And finally, you can run it using the Java command. Run the program from the command line. Don't forget to include your message after the program name. I'm estimating that this will take you about 10 minutes to do. So go ahead and give it a try. Good luck and have fun. So, how did you make out? I hope you're able to compile and run your program from the command line. It's pretty cool, right? Let's take a look at my solution. Remember that your solution might be very different. All programmers program a little bit differently. We'll start with the code. At the very top, I had to remember to import my java.util.scanner. Line 2 is where I declare my class, name and age. Line 3, I have my public static void main. Then I read in the value that the user entered as the command line argument into the variable called prompt. I use that value to print that back out to the screen. I know the user is going to type in a string and an integer, so I create a string for the name and an integer for the age. On line 9, I create my new scanner object. Scanner in equals new scanner system.in. Then I read in the name equals in.nextLine, and I read in the age in.nextInt. I don't have to parse it since this is not coming from the command line prompt. This is actually inside the running program. And then I print out whatever the user entered. I'm going to save this to my Java folder. Okay, now let's compile and run from the command line. I'm going to start using my setPath batch file just to make sure that that is set. Now I'm going to compile the program using javac space name and age.java. Now I want to run the program using the Java virtual machine. I'm going to type in Java name and age, and I'm going to give it the message that says, please enter your name and age. I'm going to use double quotes around my message because I want it to be considered one argument. When I hit enter, I get the message, please enter your name and age. I'll put in Peggy Fisher, and let's just say I'm 21 for today. My program prints back out, hello, Peggy Fisher, nice to meet you. You are 21 years old. If you didn't get it to work, don't be discouraged, go back and try it again. Make sure you set the path variable before trying to compile and run the program. After it is working, try making some other programs using brackets and challenge your Java skills. Have fun! At this point, you should already have downloaded an Integrated Development Environment, or IDE, and be familiar with using this IDE. For this series, I'm using NetBeans. But if you prefer to use Eclipse or BlueJ, which are also free interactive Java development environments, that's fine, and most of the examples are easily adapted to those environments. If you need help downloading an integrated development environment, please see Up and Running with Java on lynda.com. As you know, Java is a strict data typing language. That is, every variable must be declared with a data type, and your program cannot change the type of data stored in that variable. For example, if you declare a variable to store numbers, you cannot try to store strings in the same variable. You would get an error message, incompatible types, string cannot be converted to int. Each programming language has the same basic parts. Let's do a quick review. Comments. Comments can be single line or multi-line. Variables include the data type and the name. Expressions, which are equations or statements. Decisions, such as if something is true. Loops, which allow the program to repeat. Input and output, which can be from the console or files. And methods. Some languages refer to methods as functions. And there are more parts, but those are the ones we want to concentrate on for now. Let's take a minute to quickly review expressions with data types. Here is an example Java program with the data types we just reviewed. On line 12, we declare a character variable called letter, and we assign it the value capital A. Notice the single quotes for characters. Then we have a Boolean variable called done, and it's set to false. Boolean variables can be true or false. We have an integer variable called radius, and it is set to the value 10. We have a byte variable called red. Sometimes byte variables are used to hold the saturation level of red, green, and blue when trying to create colors. In this case, I have red set to 127. A byte can be from -127 to +127, or unsigned values from 0 to 255. On line 16, we have a data type called short. It's also an integer, but it's much smaller than an int. Short age equals 21. Sometimes you need to hold a very large integer. Then you want to use long. And finally, rational numbers such as float and double. Notice that when you declare a variable of type float, you need to include the f after the number, 10.59f. And finally, we have a string variable name equals double quotes Peggy Fisher double quotes. Strings are not technically a primitive data type, but since they are used so often, it is usually included when discussing primitive data types. Strings are actually variables that are stored as an array of characters. Okay, so what does it mean when I'm talking about primitive data types versus structured data types? The data types we just discussed are all primitive data types. The other type is structured, and we will discuss them more when we get to arrays, classes, and objects. Primitive data types store their values directly in memory, such as int x equals 5. In memory, x has the value 5. Structured data types, such as a string that's called fruit and is set to the word apple, creates a reference value or the address of the location in memory where the data exists. In this case, my variable fruit has the address @31EB494E. That's the hash code for where the data is located in memory. Later, we'll talk more about objects and classes, and it's helpful to know that every primitive data type has a corresponding wrapper class. This allows us to create objects that contain values such as integers, characters, etc. For example, int has a corresponding wrapper class called integer. Double has a corresponding class called double. Notice the capital I in integer and the capital D in double, as well as the B in Boolean and the C in character, because classes always start with a capital letter. This was hopefully a review for you. If not, you might want to go back and review Up and Running with Java. Now that we've had a review of data types, let's talk about adding decision-making logic in Java. When adding decision-making logic in Java, the programmer often uses relational operators to compare two values, such as less than or equal to, greater than or equal to, equals, which remember is two equal signs, or not equals. Do you remember what the not symbol is? It's the exclamation point. Shift 1. In addition, sometimes it is necessary to join two or more statements. This can be done using logical operators and, which is two ampersands, and or, which is two pipes. Remember that the result of any comparison is always a Boolean value, either true or false. Here is another example program with some decision-making logic added. Let's take a look. I start out with a print line statement that asks the user to enter their age. We read that value in on line 14, int age equals in.nextInt. Now we use the relational operator less than to compare the value entered by the user to determine the age grouping of this person. If the age was less than 2, it's going to print out infant. Else, if the age is less than 12, it'll print out child. Notice that I don't have to worry about the lower limit because I took care of that with my first if statement, and I have an else if for the second part. This continues to print teen, adult, and then if you don't fit any of those categories, meaning that you're over 65 or equal to 65, it'll print out senior. Let's run the program quickly to test it. If I put in the value of 2, I should get child. It's not less than 2. I get the word child. And let's run it one more time with a value greater than 65. Let's try 70. 70 gives me the value senior. It looks like our decision-making logic is working. One thing I wanted to point out is that don't forget you can't use these relational operators when you're working with string variables. Instead, you need to use the string methods such as dot equals, or dot equals in your case, or even dot compare to if you want to compare them lexicographically or alphabetically. So use those for comparison and not the relational operators listed above. Java has 3 types of loops. We have a do-while, which is a post-test loop, a while loop, which is a pre-test loop, and a for loop, which is also a pre-test loop. Each loop has a specific purpose. The do-while loop executes the code at least once, since it doesn't check the status of the condition until after executing the code in the loop. While loops repeat as long as the conditional statement is true. In other words, the loop continues while a condition is true. And the for loop executes a predetermined number of times. This type of loop should be used when you know how many times to execute the block of code. The for loop syntax is much different than the while and the do while. It has 3 parts: initialization, test condition, and the update. This is an example program that implements the 3 loops presented above. Most of the programs we include from this point forward contain loops, so you'll see lots of examples. An example of a program that can make use of the do-while loop is a program that provides the user with a list of menu items. The program needs to present the user with the list at least once. Let's take a look. This is the first loop. On line 15 is the start. Do, open curly bracket. It prints out a list of menu items. While, here's the condition. While the choice is not equal to 1, and the choice is not equal to 2, and not equal to 3, and not equal to 4, and not equal to 5. It'll keep going until the user enters a valid choice. Once they do, we'll use a switch statement to print out a message. If they chose 1, it'll say, you chose a hot dog, that is $1. You can see we had to present the menu to the user first before asking them to enter their choice. That's why a do-while loop is a good choice for this type of program. Next, we have a while loop. If we took out a simple loan of $5,000, how many months would it take to pay it back if we paid $500 per month? What would be the loop condition? How long would you keep running this? It has to be something that changes every time through the loop and eventually allows the loop to end. In this case, it would be when the loop is totally paid back or equal to 0. Once the loan balance reaches 0, it will not continue to perform the loop. Let's take a look. Double loan balance equals 5,000. We want to keep track of how many months it takes. On line 49 is our while condition. While the balance is greater than 0, subtract $500 and add 1 to months. As soon as the loan balance is less than or equal to 0, it'll print out the message with the number of months. Finally, we have a for loop. This for loop prints all the odd numbers from 1 to 100. We use this to show how to use remainder logic in addition to writing a loop that knows how many times it needs to run. We know we want to execute the block of code 100 times. So let's look on line 58. For int I equals 1, as long as I is less than 99, add 1 to I. I stopped at 99 because 99 is the last odd number, and I want to print that at the end with a line break. Inside the loop on line 60, I check to see if the value of I is evenly divisible by 2. If I %2, which is remainder division, is equal to 1, that means it's an odd number, and I print it out. Okay, let's run this program and see our loops in action. The first thing I get is my menu. I'm going to go ahead and choose a hamburger. It says you chose a hamburger that is $2.50. Because the while loop and the for loop do not require any user input, they just went ahead and calculated how many months it would take to pay back our loan, which was 10 months, and it printed out all the odd numbers from 1 to 100. It is important to understand each type of loop so you know which type to use for each situation. An easy way to remember is do while always executes at least once. While loop continues until some condition is found to be false. And finally, the for loop is really useful when you know how many times you want to execute the loop. Let's review the process of creating our own user-defined methods. A method is a group of statements used to accomplish a specific task. It is sometimes referred to as a black box, and it helps to reinforce encapsulation. Methods can only return a single value, or the method might not return anything. The return value from a method can be a primitive data type or a data structure. When a method does not return a value, it is considered a void method, and the keyword void is put in the method header in place of the return type. When we write methods, any variables that are defined inside the method are considered local and only visible for the duration of the method body, starting with the open curly bracket and ending with the closed curly bracket. To make a variable accessible to all methods in a class, you can declare them in the class but outside of any specific method, and this is considered a global variable. By using methods, we are encapsulating the process used to update and retrieve data. This is a critical component that is used extensively when we start working with classes and objects. Most methods include parameters or arguments as a way to pass values from the calling method. There are two types of arguments, call by value and call by reference. The biggest difference is that the call by reference allows the method and the calling program to both point to the same address that contains the value of the variable. Therefore, if the method changes the value of that variable, it is reflected in the main because they are the same values. The call by value makes a copy of a variable contents, and therefore any changes are not reflected in the calling program. All primitive data types are call by value automatically, and all structured data types are automatically call by reference. Okay, let's take a look at a program that includes user-defined methods. This program is set up to calculate the cost of a list of grocery items. It includes 5 user-defined methods. getTotal, which calls getItemPrice and getItemName. getItemName, which returns the name of the item. It returns a string. getItemPrice returns the price of one item, which would return a double. getItemQuantity tells us how many of the item they want to buy and returns an integer variable. And finally, the print method prints the total, including some formatting. Let's take a look at each method. So my main method only calls 2 methods, getTotal and print. Inside the getTotal method, starting on line 17, public static double, getTotal. This returns a double. Inside of this method, I use a while loop to allow the user to enter more items. I continue to run the loop until the user tells me they do not have any more items. When I'm done, I return the total of all the items. On line 33, we have public static string getItemName. This method prompts the user for the item name and returns that name to the calling method. On line 40, we have getItemPrice. In order to get the item price, I pass a string called value that contains the name of the item. That way, the user sees a message that says enter price for, and it prints out the item, milk. I read in the price of milk, and then I return that value back to the calling program. Next, I want to get the item quantity. So on line 55, I have public static int getItemQuantity. This method prompts the user for the quantity and returns that to the calling method. And the last method that I wrote was public static void print, which takes in a parameter double total. Do you remember what I said about call by value or call by reference? What would double total be? Remember, all primitive types are call by value. So what happens is, in the print method, there's a new variable called total. And if I change that in my print method, it does not change it in the calling method. Okay, I want to go ahead and run this to give you an idea of how it works. Enter the item name. I'll go ahead and get some milk. I always need milk. And the price for milk is $3.90. Then it says, how many of these items did I buy? I only want 1 gallon of milk. Let's go ahead and add another item. Let's get bread. The price for bread is $2.39. But I'm going to get 2 loaves of bread. At At this point, I'm going to say no, I don't have any more items. And it printed out the total of my grocery items is $8.68. Thanks for shopping with us. So, as you can see, this program contains several user-defined methods, and I'm actually calling one method from within another method. Go ahead and take a look at the program and try making some changes on your own to see if you understand how it all works. Sometimes, when writing your programs, you might want to create the same method twice, but with slightly different values as arguments, or maybe even a different return type. Two or more methods may have the same name as long as the list of parameters or arguments, or the return type is different. When this happens, it's called overloading. You overload the method. For example, if you want to write a method that finds the average of three numbers, you might want to allow it to use three integers, but you also might want to allow it to use three doubles. The logic is the same, but the type of data sent by the calling program is different. So you would create two methods with the exact same return type and the exact same name, but they would each have different arguments. One would have three ints and one would have three doubles. Again, this is called method overloading. Now let's take a look at the example I have here. I have updated the program that we worked on in the last section to calculate the total amount of groceries. And I've added another print method that contains the name of the store. The method is exactly the same except it contains an additional string argument for the store name. Let's scroll down and take a look. Here are my two print methods. They're both public static void print. The top method just takes in a value for total. The second version takes in total, comma, string, store name. In the main method, if the user enters a valid store name, then the total and the store name are passed to the print method. The computer knows which method to call based on the parameters or arguments listed in the method call. Let's go back to the main. In the main, on line 14, I ask the user if they know the name of the store, or none if they don't. I read that in, and then I check to see on line 18 if the store name is equal to none. Then I call the print method that does not include the store name, print total. Otherwise, I call the print method that includes both the total and the store name. Let's try it. We'll do it both ways. The first time, I'll say none. I'll go ahead and order my milk again, and we'll put in $3.89. We want 1 milk. This time I'll say, let's get some eggs in addition to our milk. And the price of eggs is $2.50. And we'll get 2 of them. Okay, that's enough for today, so no more items. And it prints out my total cost as $8.89. And it says, thanks for shopping with us. Now, if I run the program a second time, and this time let's put in the name of a store. I'll use Giant. Now it asks me the name of my item. Again, I'll do milk just to keep things the same, and I'll use $2.89 for my milk, and I'll get 1 milk. And I'll get another item, I'll get some eggs, and I'll say that the eggs are $2.50, and I'll just get 1 dozen. And that's all the items I want, so I'll say N for no more items. This time it says, the total for your grocery items is $5.39, and it says thanks for shopping at Giant. You can see the second time it used the name of the store and printed that name out in the message. Overloading methods is especially useful when we start working with classes and objects. When we create a class to represent an instance of an object, we use a constructor to build the object. This is where overloading is helpful, since we might want to allow the user to create objects using different default values. Maybe a partial list of values, or even maybe the entire list of values. So we can create several constructors using method overloading, which allows the program to choose the right method. It's time for your next challenge. In this challenge, I want you to write a program that computes and displays the total yearly expenses for a student in college. The student might be living on campus or in a nearby apartment or commuting. If the student is living on campus, we need to ask for the number of weeks they'll be living on campus, the duration of stay, the estimated weekly living expenses, not including room and board, and the cost of room and board. For all students, we need to also ask for their name, What year are they entering? Freshman, sophomore, junior, senior? The estimated cost of textbooks, pencils, paper, all the supplies that they'll need for the year. The number of credit hours they're taking, and the cost for each credit hour. Use that information to calculate the total cost for attending college for 1 year and print the final total. Write separate methods for each request and only use the main method to call the other methods. This challenge should probably take about 20 minutes. It's a little more challenging than the first one, so take your time and have fun. This challenge was meant to refresh your skills of working with various data types and working with methods. Let's take a look at my solution, and remember, your solution might be very different. At the top of my solution, I have my main method. Inside the main method, I only call two methods, just like before. I have on line 32, string name equals getName, and then 33, I have print total, and I pass the name of the student to the print total method. Let's scroll down a little bit. In the print total method, I have a parameter that brings in the name as a string. Then I check to see if the student is on campus by calling the onCampus method, which returns a Boolean variable of true if they're on campus or false if they're not. On line 46, you can see I'm actually calling several methods within the statement that says total is equal to calculate total expenses, and I give it the estimated living expenses, the books and supplies, the credit hours, and the cost per credit hour. If the student is not on campus, then I don't need to know what the estimated living expenses are. Then I get the year, and finally I print out the total cost for the student name is, and I print out the value. Let's scroll down to the other methods. Here's the Boolean onCampus method. In this method, I ask the user if the student is living on campus. I return true if they are or false if they are not. Under estimated living expenses, I ask how many weeks the student will be on campus, and then I get them to estimate the weekly living expenses, and finally I get the room and board. I add them all together, multiplying the number of weeks times the weekly expenses, and return that to the calling program. The books and supplies method asks the user to enter in the amount of books and supplies and returns that value. Then we have credit hours, which returns an int, and cost per credit, which returns a double. And finally, I have an overloaded method, public static double calculate total. Notice that's exactly the same on line 125 and line 131, but on line 125, I have an extra variable for living expenses. So we can have the same return type and the same method name as long as the parameters or arguments are different. In this case, the first one on line 125 is calculating the cost for someone who lives on campus. The second on line 131 is calculating the cost for someone who commutes. All right, let's go ahead and run the program. Let's enter the name of our student. And let's say that Joe is living on campus. He'll be on campus for 36 weeks, and he plans to spend about $375 on weekly living expenses. Room and board for the year is $14,000. Textbooks is $350. Credit hours. He is planning on taking 15 credit hours each semester, so I'll put 30. Each credit hour is $900. And this particular student is going to be a sophomore. Now that I entered in all the data, my program calculated the total cost for 1 year for Joe Smith as a sophomore to be $54,850. Okay, let's try it again with someone who's commuting. We'll say Jane Smith this time. And we'll say that Jane is not living on campus. She still has to buy textbooks and supplies, so we'll say that's about $400. She's also planning to take 30 credit hours for the year, and each credit hour still costs $900. She'll also be a sophomore. The total cost for Jane is going to be $27,400. Quite a reduction because she doesn't need to pay for room and board. If you didn't get a chance to try this program first, go back and try it again. It doesn't have to be exactly like this solution. Make sure you create your own. For an additional challenge, try adding logic to allow the user to calculate the cost for more students by adding a loop. I hope this activity helped to reinforce the topics from this section. The ability to successfully debug a program is one of the best tools to have in your toolbox of programming skills. There are two main types of errors that we will review, both syntax errors and logic errors. A syntax error occurs when we make a mistake in our coding, such as forgetting a semicolon to indicate the end of a statement, or maybe mistyping. A logic error is sometimes harder to find. This occurs when we have all the correct syntax, but we coded a portion of the program with an error, such as possibly dividing by 0. Most IDEs, or integrated development environments, have built-in debugging tools. The advantage of using this debugging tool is that it allows us to control each step in the program, and we can watch the variables as they change. Later in this section, we will also review how to debug your program from a console window using command line debugging. Let's start with debugging inside the NetBeans IDE. I have a grocery project file open. It's helpful to enable the line numbering feature. If you don't see line numbers, go to View and click on Show Line Numbers. That toggles the line numbers back on. Now we can add a breakpoint. Breakpoints enable the programmer to stop and take control of the program execution. This can be done in 3 ways. First, we can right-click the number column on the far left in the editing window. So I'm going to click on line 14. We can go to Breakpoint and choose Enabled. We repeat the same procedure to remove the breakpoint. Right-click, Breakpoint, and click on Enabled to deselect it. The second way to add a breakpoint, make sure you have the line selected where we want to stop. Go to the top, go to Debug, and choose Toggle Line Breakpoint. Now a breakpoint is set. You see the red square on the left-hand side, and the entire line is highlighted in red. The third option, and probably the easiest, is to simply click in the gray column area to the left of the line where you want to add the breakpoint. I'll add another breakpoint to line 17 to show you how that works. And again, to deselect it, you just toggle it again. It's important to note that the breakpoint indicates the next line of code that will be executed. Once the breakpoint has been set, we can run in debug mode. Go to Debug, and then choose Debug File, or you can choose Control F5. In the last video, as you can see, the program stopped on line 14 before executing the statement. The debugger has added several additional buttons to help you with debugging in the top part of our screen. We have a button to stop or finish the debugger session. We can pause. We can continue if we want the program to continue running normally. We can step over an expression, or step into. This is the one we'll use the most, to step into the code one statement at a time. And we can step out, or we can run to wherever our cursor is. The other thing that's really nice is as our program is running and we are debugging, we can watch the window below to see the variables and watch how they change. Down at the bottom, I have a new variables window, a breakpoints window, and right now I only have one breakpoint set on line 14, and our output window. Let's use the step into to watch the program execute one statement at a time. So if I click on Step Into, you see now it says Enter Name of Store or None if unknown. I'm going to go ahead and enter Hoyt's Grocery Store. When I click in Hoyt's and hit Enter, control is passed back to the program. Now I'm going to click on Step Into. At this time, the store name should have the name of the store, Hoyt's. Let's check. I'm going to go to my variables, and you'll see it added a variable, store name, and it has the word Hoyt's in it. The next line of code to be executed is line 16, which is going to put a 0 into the total. I'm going to step into, and again, you can see it put 0.0 because total is defined as a rational number, a double. At any time, we can use the green arrow to continue normally. But let's step in again. The logic jumped to the getTotal method. The first thing it's going to do is declare a new variable called total and set it to 0. Then it's going to create a Boolean variable, more items, and set that to true. And now it's going to say while more items, it's going to call the get item name. If I go back over to my output, we'll see that it wants us to enter in the item name. Let's go ahead and get some more milk. Okay, I hit enter. I'll click the step into, and now I'm in the get item price method. And if I mouse over the word value, you'll notice it tells me that this variable value has the word milk in it. I could also go to my variables to see that as well. I need to go back over to the output and click on Step Into. Now I can add the price of milk. So let's make it $3.89. And we'll hit Enter. We'll click on Next. Click Next again. Let's go back over to Variables. Now the price variable is changed from 0 to 3.89. And the next thing it's going to ask how many milks we want. So let's step into. We're going to go to the Get Item Quantity. I'm going to click Step Into again so that in my output, I'll be able to add the quantity. I'm going to get 1 gallon of milk. I'm going to go back up to Step Into, and it's going to return the quantity to the calling program. Let's go back to our variables, and you'll see that we still have a price of $3.89. And if I step into, it's going to take quantity times price and return that value to the calling program. Okay, now if I click Step Into, the total will change to add the $3.89 from the calling program. This process will continue. At this point, I'm going to go ahead and click Continue to just get out of debug mode and allow the program to end normally. Since I only bought one item, the total for my grocery items is $3.89. And it says, thanks for shopping at Hoyt's. As you can see, this gives you complete control over the program. You can look at the variables, see how they're changing, and this is great for finding logic errors. Keep in mind that as your programs get more and more complex, it is really helpful to be able to use the debugging tool that comes with the IDE. If you're the type of programmer that prefers to use the command line to run your programs, we can still do debugging. There is a command line debugger available within the JDK. The debugger is called JDB for Java Debugger. The first thing we need to do when we're in our command window is to make sure that we still have our path set. So I'm going to use my batch file, and I'm going to type setpath.bat. Now, it's a good idea to recompile your program using the -G option. This generates all the debugging information. So let's do that. I'm going to do Java C, copy the exercise file for this video to your My Java folder to follow along. I have a program in my My Java folder called debugdemo.java, and I'm going to use the -G option. Okay, now I'm ready to use the Java debugger that's included in our JDK environment. So to debug the program, we type in JDB. Then we type in the name of our class, debug demo. And our particular program requires that we pass in a message. So I'm going to say, welcome to lynda.com. Now I need to specify the debug information. So I'm going to do -x debug space -x run jdwp : transport equals st_socket, comma, server equals yes equals y, address equals 8,000, and suspend equals y. I'm going to hit enter, and it says it's initializing the JDB. At this point, I want to go ahead and set my breakpoint before I run my program. So I'm going to say stop at, and again I list the name of the class, debug demo, : and the line number. I'm going to use line number 5. I'm going to hit enter, and it deferred the breakpoint because I haven't actually run the program yet. Now I'm going to type in run. As you can see, the virtual machine is started, and I'm at my breakpoint. Breakpoint hit. It says line 5, and line 5 says system.out.println message. Okay, now I can do a few things here at my main prompt. I'm going to go ahead and list the entire code. So I type in the word list, and it prints out the code for me. This is my debug demo program, which has a main. It sets the string message variable to the first argument from the parameters, which in our case is welcome to lynda.com, and then it prints it back out again. One nice thing for debugging is I can print out the different values. So let's go ahead and print args bracket 0 bracket and see what that has in it. Okay, good. It has our welcome to lynda.com message. Let's print out the message variable. It also has welcome to lynda.com. Our program is rather short, so there's no other variables that we can look at. So I'll go ahead and say continue. My program will print out the message, welcome to lynda.com, and end. You can get help at any time to get a list of debug commands by typing in the word help at the command prompt. This has been just a brief introduction to the use of command line debugging tool, JDB. Use the help command to get more information about all the options and settings that can be used with the command line. The challenge for this section is a little different. First, you want to open the challenge file for this section. It contains several logic errors. Read the code carefully and write down your expected results. Run the program normally and compare the answers from the program to what you wrote down. Now use the debugger to set breakpoints and find the errors. Hint, there are at least 3 errors. Make the corrections to the program and rerun to make sure that it works correctly. This challenge is designed to give you an opportunity to use the skills learned in this section. For a real challenge, try the command line debugger. It should take about 5 minutes. Okay, give it a try. Welcome back. How did you make out with your challenge? I hope you're able to find the errors. I'd like to show you how I would approach this problem. As I stated earlier, the first thing is to figure out what the expected results should be. The first part of the code allows the user to enter a set of numbers and find the average. The second part says, okay, I'm going to give you the numbers 3, 5, and 8, add them together, divide them by 3, and print out the average. And the last part is converting from Fahrenheit to Celsius. It's starting with a Fahrenheit value of 212. So, my expected values for the first part, I'm going to enter 3 numbers, 10.5, 15, and 7.5. So I expect the total to be 33 and the average to be 11. On line 28, it should print out the average of 3 plus 5 plus 8 divided by 3, which should be 5.33 repeating. And finally, using the formula for Celsius equals 5/9 times Fahrenheit minus 32, I know if Fahrenheit is 212, the Celsius should be 100. Let's run the program and see what we get. I'm going to enter 10.5, 15, and 7.5. I'm going to type in Q to quit, and there's my results. But they don't look like what I was expecting. The average is infinity. That should have been an 11. The second average is 5.0, but it doesn't have the decimal portion of 5.333 repeating. And finally, the Celsius temperature is 0. Okay, it's not evident at first sight what's wrong, so let's add some breakpoints to our program. Let's set a breakpoint on line 24 before I print my average, on line 28, so we can look at the average of the 3 numbers 3, 5, and 8, and on line 33, so we can figure out why we're getting 0 for Celsius. I'm going to run in debug mode. So I'm going to right-click on my file and say Debug File. I need to enter my numbers. I'm going to enter the exact same numbers, 10.5, 15, and 7.5. I'm going to enter Q because those are all the numbers that I want to enter. Okay, now it looks like the program has stopped, and you can see the green line is showing me what's going to execute next. So let's see if we can figure out what's going on. I'm going to open the Variables window down the bottom. And in the Variables window, we can see that we have a count variable that has a 0 in it, a total of 33. It looks like I'm trying to divide 33 by 0. That's why I got the value infinity. I forgot to increment the count variable every time I read in a new number. Okay, I can fix that. Let's go on to the next one. Okay, the average is, we can see the AVG variable has 5.0. Why does it have 5.0? Well, let's look at the calculation. It's adding 3 plus 5 plus 8. All three of those numbers are integers. And if I divide an integer by an integer, I'm going to get only the integer portion of the result. I forgot all about that, so I'm going to have to change one of the values, either 3, 5, or 8, or the dividing by 3, to include a decimal so I get the correct average. Okay, 2 down and 1 to go. Let's take a look and see why Fahrenheit's not working. Okay, the Fahrenheit value is 212. That looks okay. Now I'm going to calculate the Celsius value. And again, Celsius is 0. Well, why would that be? The Fahrenheit value of 212 minus 32 is okay, but the 5 divided by 9 is 2 integers. Since 9 goes into 5 0 times with the remainder of 5, when I try and do 5 divided by 9, I'm getting 0. So 0 times any value is going to be 0. All right, I think I know what my problems are. I'm going to stop the debugger, see if I can correct my problems, and rerun the program. Okay, the first thing I need to do is to increment the count variable every time I read in a new number. I'll do count plus plus. Next, I need to change this so that I get a double as a result. So I'm going to divide it by 3.0. That will cast my number as a double. And I'm going to do the same thing here with the Celsius. I'm going to make it 5.0 divided by 9.0. I feel pretty confident in my results, so I think I'm just going to run the program. So I'm going to say run file. I'm going to enter in my numbers again, 10.5, 15, and 7.5. Q to quit. There we go. The average is 11, which is what I was expecting. The second average is 5.33 repeating, and now the Celsius is 100. If you didn't find those errors the first time around, I hope you had a chance to at least try the debugger. If not, take the time to do that. It's a great tool to have in your toolbox. I'm sure you've heard the term API before. So let's review the Java API. API stands for Application Programming Interface. I want to make sure you understand that the term API is not specific to Java. You'll find APIs for Android when you're trying to write an app for your Android phone, Python, and almost all languages have their own API. In Java, most basic programming tasks are performed by the API's classes and packages. By using the API, it reduces the amount of code necessary for the programmer to write to perform common operations, such as reading and writing from the console, reading and writing from files, math calculations, such as square root, sine, and cosine. These are all common operations that we all use in most of our programs. The benefit is the API contains classes and methods that have already been developed and tested, so we can reuse these without reinventing the wheel. The Java API is a collection of software packages, classes, interfaces, with their respective methods, fields, and constructors. Programmers can use this pre-written code for graphics, user interface components, networking, if they want to add sound to their program, or maybe access a database. We've already mentioned the math class, which includes many math operations that you might need to use. Okay, let's talk about how to actually use all these libraries. In order to use these specific methods, we have to import the necessary libraries by adding them to our program. The API is included in the Java JDK, but we still need to specify exactly which packages we want to use. Some sample packages available in the API include java.lang. This one is imported automatically for us. You don't have to do anything to use this particular package. It includes wrapper classes, the comparable interface, and exception handling classes. Another important package that we use is java.util. The java.util contains classes for date and time, for the scanner class, which we'll use extensively for reading and writing from the console or reading and writing from files, and array lists. The java.io package allows us to do file processing. Java.awt is used for painting graphics. And the javax.swing allows the programmer to use the graphical user interface components. In addition to these commonly used packages, The API also includes javax.crypto, which provides classes and interfaces needed for cryptographic operations, javax.image.io, which allows you to work with images, and many more. See the Oracle site for more information about other classes and packages available in the API. Now I'd like to talk about the term JAR. JAR is referred to as a jar file, and the jar in jar file stands for Java Archive. It's commonly used to combine several classes into one compressed file. Jar files are created either using the utility jar.exe that's provided in the Java JDK, or you can create your jar file in your IDE, your Integrated Development Environment. In this section, I will describe creating jar files from both the command line and in the IDE. Let's start with the command line version. Before making our jar file, we need to get all our classes and manifest file together in one directory. Let's use Windows Explorer to create a new folder called Geometry inside our My Java folder. Now, we can copy all the files from the 0402 exercise folder into the Geometry folder. We're all set now. We can work with the files in the console window to make our jar file. To make the jar file runnable, you need to create a manifest file that specifies which class contains the main method. A manifest is a one-line text file with a main class directive. First, I want to show you what's included in my Geometry folder, so I'm going to type in dir. You can see in the folder on the C drive, under My Java, Geometry, I have all the classes that I need, as well as a manifest.txt. I want to show you what's in my manifest.txt. In brackets, I have the manifest.txt open, and it simply has main-class, capital M, capital C, colon, space, geometry. And then I have an end line symbol. That's why you see two lines. Your main class line must end with a new line, and there must be a space after the colon. You can create a manifest file in any text editor. You can give your manifest file any name, too, but it's better to use something standard, such as manifest.txt. Again, the manifest file specifies which class contains the main method. Let's go back to our console. Once you have your manifest and all your classes have been compiled, you need to run the JDK's jar.exe utility. It is located in the JDK's bin folder, the same place where javac.exe and java.exe are located. I'm going to run my setPath command from within my Geometry folder so I make sure that I'm pointing to the right JDK. In order to do that, I need to tell the computer to go back up one level. I type in ../setPath.bat. Okay, now I have the path set, so I'm sure I'm pointing to my JDK. Now I'm ready to execute my jar command. I'm going to type in jar space cvfm space. I'm going to call my jar file mygeometry.jar, and I'm going to provide the manifest file manifest.txt. And finally, I'm going to use a wildcard to specify all the class files that are in this folder. That will include all the files that you see above. Before I actually create the jar file, let me just go over what the CVFM stands for. CVFM stands for Create a Jar, Show Verbose Output, specify the output jar file name, specify the manifest file name. Okay, let's hit enter. It says it added the manifest, it added the class files that I had in my Geometry folder. Everything looks good. Once the jar file is created, other programmers can now use my classes and methods by importing the new jar file. It's a great example of code reuse. The jar file contains all the compressed data for your classes and methods. Let's take a look at the directory. As you can see, it has 3,575 bytes and it's called mygeometry.jar. Okay, now let's look at the NetBeans IDE. I have two projects created. The first one is what I'll use to create my jar file, and under the source packages, under the Geometry package, you can see it has all the .java files. I still need to create my class files, and I'll do that by running the clean and build utility within the IDE. In order to create the jar file, right-click the project name Geometry. Go down to Properties, and under Properties you'll see under the Build, click on Packaging. Notice the compressed jar file box is not checked. Go ahead and check that and click OK. That tells the compiler to create the jar file when I clean and build my project. Now I'm going to click on the hammer and the brush in order to clean and build. And down the bottom it says Finish Building Geometry, Clean Jar. So now I have a jar file created. Let's open up my geometry package. Under Source Packages, under Jar Test, I created a little program called Jar Test. As you can see, I want to use the classes from my geometry jar, the shape class, the circle class, and the rectangle class. Right now, it's giving me an error because they don't exist. So I need to right-click on the libraries and say Add Jar. So I need to add the jar file from my NetBeans projects, from my geometry, which was the name of my geometry package that has the jar file in it, under DIST for distribution, and there it is. I'm going to click on Geometry, and I'm going to click Open. Okay, now if I expand libraries, you'll see there is the geometry.jar. Okay, the next thing I need to do is just to import it. So let's do import geometry.**. And that will allow me to use all the classes and objects created in the geometry project. Okay, in my jar test, I'm going to run this, and it's going to create a circle and a rectangle. Let's go ahead and try it. We'll make the radius of the circle 10, so it's easy to calculate the area in our head. 3.14 is pi, so if a radius is 10, then the area of the circle is pi r squared, so that's 100 times 3.14. Okay, let's enter the length of a rectangle. So let's do 10 and 30. Make it nice and easy. The area of the rectangle is 300. As you can see, by importing the geometry package, the jar file, I now have access to both the shape class and the circle class and the rectangle class. This is a great example of how code reuse is made easy in Java. Make sure you give it a try. When programming, it's really important to remember that you have to account for potential user errors. Most programming languages have code that helps handle unexpected errors. It provides the programmer control over the exception so they can provide meaningful messages and avoid program interruptions. This program reads a series of numbers from a text file. I created a text file in the IDE called numbers.txt and added a few numbers. The program is designed to read the numbers, and at the end of file, it will calculate the average of the numbers. Let's take a look at the program and the error logic that I added for both any input file errors that might occur and any potential null pointer exceptions that might occur. At the top of the program, you can see I had to import the java.io to get the library that allows me to read and write from files, and the java.util because I need to use the scanner object. Let's start by looking at line 17. We have our normal public static void main, but now we've added something that says throws file not found exception. That's because in our code we're reading from a file, so we need to be able to handle or catch that file not found exception. We start by creating a string to hold our input file name because we're going to ask the user to enter the file name. We then create a scanner object in to read from the console. We ask the user to enter the name of the file, and we read that file name into the variable input file name. On line 22, I'm creating a scanner object that is going to allow me to read from the file, so I named it inFile, and I set it equal to null to start. I created a variable to hold the total of all the numbers, and another variable to keep track of how many numbers there are, so I can make sure that I calculate the average correctly. Now, here's where the error handling code comes into play. We have this new keyword, try, and it says inFile equals new scanner, new file, input file name. While the inFile has another number, so while inFile that has next double, I'm going to add that value to my total. For now, I commented out the count ++ to show what happens when we try to divide by 0. After I'm done reading the file, I'll print out the average by taking the total divided by count. Now notice the corresponding catch. Every try must have a catch. The catch statement is included for when file not found exception occurs. It'll create a new object. In this case, I named it file. Then I printed out a message inside of my catch statement that says input file was not found, try again. I also added a finally clause. This clause will be executed whether or not there is actually an error or the program runs successfully. It's helpful to make sure that you close all your files before ending your program. So in the finally clause, I have another try. I say infile.close, and I'm going to catch any null pointer exceptions, because if we don't actually read the file, when I go to close it, it will cause a null pointer exception. Okay, let's try the program. If I enter in the file name numbers.txt, I should get an error because the numbers.txt is located in the error handling package. And I do. Both of my errors were caught. Input file was not found, try again, and null pointer exception has occurred. The problem is I created my numbers.txt within the NetBeans IDE, and it automatically puts it inside of the package folder. So this time, when I run the program, I'm going to provide the computer with the correct address of where the numbers.txt folder exists. So this time, I need to tell the computer to look in the SRC folder, in the error handling folder, and it's called numbers.txt. This time, it ran correctly, but it printed out the average is infinity. We saw this before when we were trying to debug errors in our program. That's because I tried to divide by 0. Okay, the last thing I'm going to do is fix that error. Run the program again. Again, specify src \error handling \numbers.txt. The average of the numbers that I put in is 10.63. The try and catch can be used for all kinds of errors, and it's very helpful in debugging your programs and also to help avoid any user input errors that might occur. Are you ready for our next challenge? For this challenge, I want you to open the file in the exercise folders under Chapter 04, Lesson 04, Challenge.java. The program is currently set up to create a formatting object for the date. It uses this to format the current date and print the results, then format the date using the France time zone. If you go ahead and try and run this program, you'll see it's not working quite correctly. That's because we need to find the Java API package for using the date and time methods. Once you identify the problems, correct them and rerun. I estimate this will take about 5 minutes to look up the Java API and review the classes to find the missing packages. Once you find the package name, add them to the top and run the program again to make sure it's working correctly. I hope you didn't find this challenge too bad, but I wanted you to get used to using the Oracle documentation to find libraries and classes that may exist that may be helpful in the future. If you went out to the Oracle site and looked at the Java API, I hope you found that the java.text library has the date formatting that we need. There's also one little secret that I didn't mention, and that's that the IDE is very helpful when it comes to missing imports. Let me show you what I mean. As you see, right now, the program does not know what date format and simple date format are. If I move my mouse over to the light bulb with the exclamation point on it, and if I left-click on that, I'll get a list of options. It says I can add the import for you, and you'll notice it says Add Import for Java.text. That's the library that I need, .date format. I'll click on that one first. But I need both. I also need the simple date format, so I'll go back over and click on that one too. There we go. Now there's no errors left in my program, and I can run it and see what it looks like to print out the date in simple date format and also using the locale.france. I'll click on the Run button, and it just so happens that today is May 13th. So the date in MMDDYYY format is 05/13/2015. Next is the France time, 13 MAI 2015. Unfortunately, I'm not real good at French, but I'm guessing MAI is May. Okay, well, I hope you had fun exploring the Oracle documentation, and hopefully you found the java.text class and were able to see all the different methods that are available. Go ahead and take a few minutes to try some of the other date formats, or maybe even some of the other locales that are available. And then, why don't you try adding another option that will allow you to print out the current time? I can't stress enough how important it is to be able to use the documentation to find libraries and classes that already exist. So if you didn't get a chance the first time, go ahead and check it out. It'll be really helpful in the future. Did you know that object-oriented programming languages were originally used most frequently for two types of applications: computer simulations and graphical user interfaces? Computer simulations attempt to mimic real-world activities so that their processes can be improved or so that users can better understand how the real world operates. Discrete event simulation is a good option for problems that can be modeled as individual events that take place at very specific times. Key activities are randomly generating times and durations based on empirical data and accumulating statistics as the simulation runs. Let's take a look at an example. You could simulate the activity in a parking garage as the entries and departures of cars and the loss of customers who can't enter because the garage is full. This can be done with two model classes, a car class and a garage class, and three other supporting classes, an event class, a schedule, and a monitor. The schedule will manage the events and the monitor will accumulate the data. Let's talk about the schedule class. The schedule class keeps a queue of events, or a list of events, ordered by event time. The schedule drives the overall simulation with a simple loop. As long as there are events remaining in the queue, the schedule takes the earliest event from the queue and sets the world clock to the time of that event, and invokes whatever action the event specifies. Now let's talk about the car class. The car class holds the inter-arrival time and the length of stay statistics. When a car arrives, it logs its arrival with the monitor, consults the world clock, determines how long before the next car should arrive, and posts the arrival to the schedule. Then it checks to see if the garage is full or not. If the garage is not full, the car logs its entry with the monitor and tells the garage it has entered. It determines how long it will stay and posts its departure event with the schedule. Now for the garage class. When a car departs, it tells the garage so the garage can increase its available capacity and logs its departure with the monitor. The garage keeps track of the cars that are currently inside and knows about its available capacity, providing the car class with full or not full status. When a new car enters, it decreases the available capacity. The monitor class keeps track of the statistics in which you're interested: the number of customers, successfully arriving cars, the number of lost customers, cars who arrived when the lot was full, the average length of stay, and the revenue based on the rate charged for parking. A sample run of this simulation would include starting the simulation by putting events into the schedule. Events are the arrival of the first car and the end of the simulation. We repeat the basic simulation loop until the end of simulation event is encountered. At that point, ask the garage to report on its current occupants and ask the monitor to report the overall statistics for the session. This is an example of a simulation that can be coded in Java to help determine the appropriate size for building a garage based on the expected number of customers at various times of the day. Another common simulation technique is referred to as the Monte Carlo simulation. A Monte Carlo simulation is a way of approximating the value of a function where calculating the actual value is difficult or impossible. It uses random sampling to define constraints on the value and then makes a sort of best guess. Monte Carlo methods vary but tend to follow a particular pattern. First, define a domain of possible inputs. Then, generate inputs randomly from a probability distribution over the domain. Third, perform a deterministic computation on the inputs. And finally, aggregate the results. A simple Monte Carlo simulation can be used to calculate the value of pi or to approximate the value of pi. If you had a circle and a square where the length of a side of the square was the same as the diameter of the circle, the ratio of the area of the circle to the area of the square would be pi over 4. So, if you put this circle inside the square and select many random points inside the square, the number of points that fall inside the circle divided by the number of points inside the square and the circle would be approximately pi over 4. The benefit of the Monte Carlo method is it allows you to perform this calculation with very high numbers of trials by using the computer simulator. Let's take a look at this example in NetBeans. In this procedure, the domain of inputs is all the points in the square that circumscribes our circle. We randomly generate inputs by simulating the scattering of points inside the square and then perform a computation on each input, test whether it falls within the circle or not. Finally, we aggregate the results to obtain our final result, the approximation of pi. Let's walk through this example. Starting on line 5, we call the getPi method 5 times. Each time we use a different number of points to approximate pi. As you can imagine, the more points we use, the closer we get. Let's scroll down to the getPi method. The program uses the random number generator available in the Math API. It randomly generates the point for x and a point for y, and then uses that value to determine whether or not the point is inside the circle or just inside the square. Let's run the program. As you can see, it starts to print out the values of pi, 3.15. As the numbers get higher, the number of trials and the number of points, we get closer and closer to the actual value. It just so happens I know that the first few numbers are 3.14159. You can see when we use the last value, we get 3.14135. Pretty close. Let's try it one more time. This time, the last value is 3.1413. We're still getting close, but we're not quite there. There is another Monte Carlo simulation in the challenge for this section, so make sure you review the code and you understand how this works. In this section, we're going to talk about algorithm analysis. Algorithm analysis is concerned with comparing algorithms based upon the amount of computing resources that each algorithm uses. We want to be able to consider two algorithms and say that one is better than the other because it is more efficient in its use of those resources, or perhaps because it simply uses fewer resources. When dealing with algorithm analysis, it is important to first think about what is meant by computing resources. For example, we can consider the amount of space or memory an algorithm requires to solve the problem. Or, as an alternative to space requirements, we can analyze and compare algorithms based on the amount of time they require to execute. This measure is sometimes referred to as the execution time or the running time of the algorithm. One way we can measure the execution time of a program is to do a benchmark analysis. This means that we will track the actual time required for the program to compute its result. You might have heard of Big O notation before. Let's talk about that. Big O notation is a relative representation of the complexity of an algorithm. So what do we mean by relative? When we're talking about relative, we're saying that we can only compare apples to apples. You can't compare an algorithm to do arithmetic multiplication to an algorithm that sorts a list of integers. But a comparison between two algorithms to do arithmetic operations, maybe one does multiplication and one does addition, will tell you something meaningful. How about representation? Big O, in its simplest form, reduces the comparison between algorithms to a single variable, making it easier for us to compare. That variable is chosen based on observations or assumptions. For example, sorting algorithms are typically compared based on comparison operations, comparing two nodes to determine their relative ordering. This assumes that comparison is expensive. But what if comparison is cheap but swapping is expensive? It changes the comparison and the complexity. The complexity, if it takes me 1 second to sort 10,000 elements, how long will it take me to sort 1 million? The complexity in this instance is a relative measure to something else. When trying to characterize an algorithm's efficiency in terms of execution time, independent of any particular program or computer, it is important to quantify the number of operations or steps that the algorithm will require. If each of these steps is considered to be a basic unit of computation, then the execution time for an algorithm can be expressed as the number of steps required to solve the problem. Deciding on an appropriate basic unit of computation can be a complicated problem and will depend on how the algorithm is implemented. Order of magnitude is often called Big O notation, where the O stands for order and is written O of a function of n. It provides a useful approximation to the actual number of steps in the computation. Big O specifically describes the worst-case scenario and can be used to describe the execution time required or the space used, for example, in memory or on disk by an algorithm. Let's talk about a couple Big O notations. Big O specifically describes the worst-case scenario and can be used to describe the execution time required or the space used in memory or on disk of an algorithm. Let's talk about some specific Big O notation. O of 1. O of 1 describes an algorithm that will always execute in the same time or space regardless of the size of the input dataset. O of n describes an algorithm whose performance will grow linearly and in direct proportion to the size of the input dataset. O of n2 represents an algorithm whose performance is directly proportional to the square of the size of the input dataset. This is common with algorithms that involve nested iterations over the dataset. Deeper nested iterations will result in O of n3 or O of n4, etc. O of 2n denotes an algorithm whose growth will double with each additional element in the input set. The execution time of O of 2n function will quickly become very large. This is just a quick overview of algorithm analysis, but I hope that it provides you with some familiarity with the terms used regarding algorithm analysis. You will quite often hear about the Big O notation. When talking about program efficiency, sometimes it's good to take a look at maybe writing your program recursively. Recursion is the process of a method that calls itself to solve a problem. Sometimes this process can help reduce the space requirement or the execution time and therefore make the program more efficient. It can call itself again and again to help break down a larger problem to solve it in smaller steps. Let's take a look at a simple example where we want to print out a countdown from 10 to 1 and then print the word blast off. So in this example, we want to stop when the number gets to 0. In the main, we print out the message the countdown has begun. Then we call the countdown method, and we give it the number 10. That transfers control to line 19, where we have our countdown method. So the count variable now has the number 10. It says if count is equal to 0, return, because that's our base. Because the method would constantly call itself with no end. So if it's not the base case, what happens is we go to line 23 and we print out whatever the count variable is at that time with a ... And then we call the method again, and we say call countdown with count -1. Now it goes back up and calls countdown with 9. This keeps happening until it gets to 0. Let's run the program. If I expand my window a little bit, you can see it printed out the countdown has begun, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. This is a very simple example of recursion. For an interesting example of recursion, check out the problem titled Towers of Hanoi. That's a really interesting example of recursion. Okay, it's challenge time. In this challenge, let's use the Monte Carlo simulation to calculate the probability of selecting a certain marble from a bowl of marbles. I want you to estimate the probability of getting 3 of the same color marbles if you randomly select the marbles from a bowl that has a total of 6 marbles. 3 are white and 3 are blue. I think for this challenge, I'd like to give you a series of steps that you can follow, or an algorithm. Start by creating unique variables, one to represent whether or not it's a blue marble, and one for whether or not it's a white marble. Add variables to keep track of the attempts and the number of successes. Then set up your loop for the simulation. Create an array to simulate the bowl. So the array will have 6 objects that hold the unique variables for blue and white. 3 of those objects should represent blue and 3 should represent white at the beginning. Create a second array that only has 3 marbles. This array holds the marbles that were randomly selected. Inside the simulation loop, create a smaller loop that will execute 3 times to randomly draw 3 marbles. Inside the loop, randomly choose 1 marble. Add it to the array that contains the marbles that were already drawn. And like I said, reduce the size of your bowl by 1. Specifically, reduce it by the one that you chose. Update the bowl without the selected marble. Once you've randomly selected 3 marbles, test to see if all 3 marbles are the same color. If they are, add 1 to your success counter. Either way, make sure you add 1 to your attempts. At the end of your simulation, calculate the success rate using the number of successes divided by the total number of attempts, and return that value back to the main program where it can be printed out. I'm estimating that this challenge will take you about 15 minutes, so have fun with the Monte Carlo simulation. Welcome back. How did you make out with that last challenge? Well, I hope you had some success. I'd like to go over my solution, and as always, remember, it might be different than yours. I have my Monte Carlo simulation set up to go through 3 different trials, one with 100 attempts, one with 1,000, and one with 10,000. Let's take a look at the actual Monte Carlo code itself. As you can see, I pass in the num trials to the method marble simulation. On lines 28 and 29, I declare 2 static variables, one to represent the blue marbles has a value of 1, and a second variable to represent the white marbles, which will hold a value of 2. On lines 31 and 32, I have 2 variables. Double number records the number of successes, the number of times all 3 marbles are the same color. Double result will be the value that takes the number of successes divided by the num trials. Starting on line 54 is my simulation loop. I'm going to scroll down a little bit. Line 36, I add 1 to my total attempts. Then I declare on line 38 my bowl, which has 3 blue marbles and 3 white. I also need to create another array that holds the marbles that were drawn out of the bowl. This is going to contain 3 values. On line 42, I have my for loop, which executes 3 times to draw 3 random marbles. Inside this loop on line 44, I'm randomly generating a number as my index into the bowl array. Then I take that marble out of the bowl and place it into the array that has the 3 marbles that were drawn. Now I have to recreate my bowl to remove this latest marble. I create a new bowl array on line 46 by reducing the size of the original bowl array -1. Then I go through a loop and populate this new bowl, but whenever I find the marble that was withdrawn, if I equals index, I skip over that marble. When I'm all done, I reassign my bowl array to the new bowl, and I continue to draw my marbles. After I've drawn 3 marbles, I check to see if they're all the same. If they are, I add 1 to my successes. And at the very end on line 68, I return my results. I take the number of successes, meaning 3 marbles all the same color, divided by the total attempts. Okay, let's run this program and see what we get. The probability of drawing 3 marbles of the same color. When I ran it with 100 trials, I got 0.12. When I ran it with 1,000, I got 0.106. And finally, when I ran it with 10,000, I got 0.0998. Well, I hope this made sense, and I hope you enjoyed going through this challenge to try the new Monte Carlo simulation. If you weren't successful with the challenge the first time, go back and try it again, or try a different simulation. But as always, have fun. As you know, Java is considered an object-oriented programming language. But what does that really mean? Classes and objects are the main focus of this section. A class is a blueprint for an object. Classes are used to represent the state and behavior of that object. For example, if we have a person class, the person would have a state, which might be their name, or their age, or both. And they'll have a behavior, such as maybe we need to change the name. They got married, or it was spelled incorrectly when the person was first added, or maybe we need to update their age. So a person has some state values, some attributes, name, age, and behaviors that we will use to update the data for this person, change their name or update their age. We use classes to model real-world objects, such as bank accounts, vehicles, animals, inventory, and movies, just to name a few. Each class contains instance data, constructors, which are special methods used to build an instance of our class. and methods, the blocks of code common to all objects of this class that represent the object's behavior. To determine the required information for the employee class, you need to conduct interviews and have discussions with the end user. For our example, we want to create an employee class for a payroll program. Therefore, we have already determined that we will need the following pieces of data: the employee first name, last name, phone number, address, employee ID, department, and title. Based on the information, here is the start of our UML diagram to model our employee class. As you can see, the top rectangle contains the name of the class, employee. The next rectangle contains the instance data about the employee. These values refer to the state of the employee. The last rectangle is the behaviors, or the methods that we'll need to be able to access employee information. We have a constructor, employee, which is used to instantiate our employees, as well as some get methods. As you can see, this model is not complete since we still need to add set methods for each piece of data to go along with the get methods. Get methods are often referred to as accessor methods, and set methods are called mutator methods. To reinforce encapsulation, it's a good idea to have get and set methods for all your data and declare your data as private inside the class. This avoids any accidental updating of the data. If you would like more practice in creating UML diagrams, please refer to Foundations of Programming, Object-Oriented Design, Introduction to the Unified Modeling Language by Simon Allardyce. Now that we know exactly what data and methods we need, let's review a payroll application that uses an employee class and an address class. In the same project folder as the main program, there are two separate files for the employee class and the address class. Let's start by reviewing the employee class. Remember, all this data was listed in the UML diagram. In the employee class, we start by defining all the instance data. Think of these fields as the attributes of an employee. These are the fields we refer to as the state of the employee. Starting on line 9, we have private string first name. Then we have last name, phone number, address, employee ID, department ID, title, and salary. Notice that these variables are all defined as private. This is how we enforce data integrity. Usually, right after the instance data, you have your constructor. Let me scroll down a little bit. The constructor is easy to identify because it has no return type and it has the exact same name as the class. In our case, that's public employee. Inside the parentheses are all of the arguments that come from the calling program that help us to populate the instance data. In this case, we have string fname, string lname, etc. Notice inside the constructor, we say first name equals fname. The value on the left is the same name as the instance data, and the value on the right is the name that comes in from the calling program. In this case, I made it a little different. It's just fname. I wanted to show you the use of the this command. So go down to line 23, and you'll notice on line 23, it has the keyword this.address equals address. The reason I had to do that is because the parameter coming in from the calling program has the word address as the name of the variable. That's the exact same name as the instance data, and that can be quite confusing to the computer. So I had to tell the computer that the value on the left is referring to the data field of the object. This.address is the instance data, and it's equal to the address coming in from the calling program. This process is repeated for the next 4 data fields. After the constructor, we need to add our methods that provide our public interface. These methods allow access to our instance data. Since our instance data is private, if the program needs to get the name or set the first name or last name as an example, you have to go through these methods. For this example, we have a method to get each piece of instance data and a corresponding set method to change them. You'll often hear these referred to as the accessor, or the get methods, and the mutator, which are the set methods. The reason that we want to do that is you'll notice that on line 57, I have a set method that allows us to change the salary. Well, we don't want the user to accidentally enter in a salary less than $10,000. So we can add code that says if value is less than or equal to $10,000, then print an error saying invalid salary amount and let the user know the salary was not updated. This prevents the user from accidentally updating the salary directly and gives us some control over what gets changed and what doesn't. You'll notice on line 62, we have public void print employee. It is usually helpful to add a method that formats and prints the information contained in the class. The last method that I want to show you in the employee class is the compare_to method. Notice this method is overriding the default compare_to method, allowing us to decide what it means to compare two employees. In this example, I have it set up to compare the salaries of each employee. In the class definition, I included the statement at the top, implements comparable. Let me scroll up and show you. On line 7, I have public class employee implements comparable. Now let's scroll back down to look at the compare_to method. The compare_to method takes in an object called t. Well, in order to use that object, I need to tell the computer what type of object it is. So I'm creating on line 89 a new variable that's a type of employee, employee EMP, equals, and I'm casting the object t as an employee object. Now I can compare the employee that came in from the calling program in the compare_to as a parameter. I can compare that to the object that this compare_to is being performed on. So I say if this.salary is greater than emp.salary, I return a positive number. Otherwise, if this.salary is the same as the EMP salary, I return 0 because they're the same. And finally, if neither is true, that means that this.salary was less than the value that came in from the calling program in the compare_to as an argument, then I return a -1. This might be a little confusing right now, but when we look at the payroll main program, you'll see how this is used. Overriding the compare_to method is a really useful and helpful technique, and we'll talk more about it when we get to interfaces later. In addition to the employee class, I've added an address class. Let's take a look at that real quick. I've also implemented comparable in the address class. The address class has instance data as well. It has two constructors. One constructor is set up in case there is no address line 2. That's the one that starts on line 24. I have a toString method that will format the address. And finally, I have a compare_to. In this case, when I compare one address to the other, I can't compare salaries. It doesn't make sense. So in this case, I'm going to compare zip codes. But if you remember, my zip code field is a string. So first, I have to create an integer variable. So on line 55, I have int zip1 equals integer.parseInt this.zipcode. That way, I can compare this zip code to the zip code of the address that came in from the calling program and use their numeric versions to figure out which one comes first. I know that was a lot of information, so take some time to review the code for both of these classes carefully. We will use them again when we start instantiating employees in our main payroll program. Let's take a minute to talk about encapsulation. Encapsulation is one of the benefits of using object-oriented programming languages. It allows the programmer to hide the instance data definitions, as well as protect the integrity of the instance data. It hides the method implementations. This ensures that data structures and operators are used as intended. Encapsulation can be described as a protective barrier that prevents the code and data from being randomly accessed by other code defined outside the class. It always helps to have a concrete example, so let's think about a checking account. Inside a checking account, you have a balance. It's declared as private, so it can only be updated using a method. One of the operations that you can perform on your balance is you can withdraw money. The withdraw method checks to make sure the balance is greater than the withdrawal amount prior to reducing the balance. This provides a way to make sure the customer cannot get overdrawn, by withdrawing more money than what is in the account. Some banks might also charge a withdrawal fee. That logic can be included in the method as well. This is an example of encapsulation. For a more detailed explanation, please refer to Foundations of Programming, Object-Oriented Design with Simon Allardyce. What is encapsulation? Okay, now comes the fun part. Let's return to our payroll application. We have created the employee and the address classes. So let's take a look at the main class, which I have open here, payroll.java. You'll notice line 10 has public static void main. In this class, we're going to be able to create objects for the address and the employee. We're then going to print the values back out again. We're going to try and change some of the values, as well as use our compare to methods. When we create a new object from a class definition, it is actually called an instance of the class, and that's why we say we've instantiated a new object. It is important to note that you must instantiate an object by using a keyword new. We can create any number of employees using this process. For our example, I'm going to create 2 employee objects, but before I can create the employee, I need to instantiate an address object. On line 11, I declare address A1. A1 is my variable name. I say equals new. There's that key word that instantiates this address. Address A1 equals new address. In the parentheses, I'm passing all the values for the address. 123 South Main Street, Cleveland, Ohio, zip code 12345. Starting on line 13, I'm creating a second address. 123 North Main Street, Willoughby, Ohio, 54321. Now I can create my 2 employees. I'm just going to name them EE1 and EE2. The first employee, again instantiated with the keyword new, says employee EE1 equals a new employee, Peggy Fisher, with a phone number, A1 for my address, my employee ID number, the department that I'm in, 003, my title of lecturer, and my salary, $45,000. On line 17, I print out the employee by using the new name of the object, EE1, dot print employee, because the print employee is a method in the employee class. Let me scroll down a little bit. Now I'm creating a second employee, Bob Fisher. He's also a lecturer. He makes a little bit more than Peggy, $45,500. I'm going to print out Bob's information as well, ee2.printEmployee. Now I want to show how we can use the compare to method. I have if ee1.compare2 and in parentheses ee2 equals 0. Okay, I'm going to jump over to the employee class just for a second. And remember that on line 23 it says if ee1.compare2 ee2. In the employee class, if I scroll down to the compare to, we talked about this earlier, but you see where it has if this, the this is referring to EE1. Dot salary is greater than EMP, and EMP represents the EE2 object that came in from the calling program in the parentheses of the compare to. I'm going to go back to the payroll program. And you can see I check to see if the salaries are equal, or if EE1 makes less than EE2, or if EE1 makes more than EE2. And finally, I want to use my compare to for the addresses, because the addresses are sorted by zip code. It wouldn't make sense to sort the addresses by salary. You can see how useful that compare to method can be. So again, I check if A1.compare to A2 is equal to 0, or if A1 is less than A2. Either way, I'll print A1 first, then A2. Otherwise, I'll reverse the order. All right, let's take a look at running this program. All the code is already in the program to instantiate the employees and their addresses, and then print out the results. Let's check it out. I'm going to make my output window a little bigger, and we can see it printed out the employee information for employee 1. The name, the title, the address, the employee ID, the department, and the salary. Right below that is employee 2. Name, title, address, employee ID, department, and salary. The next lines show that Bob Fisher makes more than Peggy Fisher. We use the compare to with the salaries. And finally, we print the addresses out in sorted order. Of course, 12345, that zip code comes before 54321. All right, before we leave, let's do one more thing. Let's change the title of the second employee and change the salary. Let's give the second employee a title of producer and change the salary to $60,000. But the first time we do it, let's accidentally type $6,000 because we do have that check in there for salaries less than $10,000. Okay, I'm going to come down here to right below where I print out my employee to, and I'm going to do EE2 dot, and you can see all the methods that I created in my employee class come up. And what I want to do is I want to use the set salary. So I need to scroll down to set salary, and I'm going to put it as $6,000. And I also want to do EE2 dot set title and give this second employee a new title of producer. To make sure that everything was done correctly, I'll now print it out again. EE2.print employee. All right, let's run the program and see how this works. Okay, if I scroll to the top, you'll see it printed out both employees again. But now here I have an error. It says invalid salary amount. Salary was not updated. But it still printed out the second employee, and you'll notice the title was changed, but the salary is still $45,500. By adding that code, it helps us to make sure that the data is not updated incorrectly. Okay, let's go back to payroll and fix it to $60,000 and run it one more time. This time we're not getting any error messages, and you can see that Bob Fisher is now a producer making $60,000. In this example, you've seen how to create a class, instantiate objects with that class type, and modify data in the class using what we call mutator methods, or set methods. In this example, you have seen how to create classes, how to instantiate objects with the class types, how to modify data in the class using mutator methods, and how to access the data using accessor methods. This is an example of encapsulation, and I hope that this made sense and you can now create your own classes and instantiate your own objects. When working with objects, we need to understand how to test for a null reference, which is exactly what it sounds like, a reference to nothing, null. This happens when you create an object which creates a variable name and an address where the data will reside, but it has not been instantiated. Do you remember what the keyword was for instantiation? I hope you said new. That's correct. For example, if we want to create an employee object, but we didn't instantiate an address for this employee, the address would have a value of null. Let's see what this looks like. Let's say we add the address object for the third employee, but we're not sure what it is yet, so we just set it equal to null for now, figuring we'll come back and fix it later. Okay, now we're going to go ahead and create the third employee. So I do employee EE3 is equal to a new employee, and this new employee is Jane Smith. And this is her phone number, 510-555-1212, and her address is A3. And her employee ID is 456789. And finally, she's in Department 001, and her title is Administrator. And finally, she has a salary of $55,000. Okay. Now what I want to do is I want to add a print statement so we can print this third employee. So EE3.print employee. Well, everything looks good because in the main I have a value for A3. It's just that A3 is null. But let's see what happens when we run it. Okay, it looks like when it went to print out the third employee, we're getting a null pointer exception. And that's because this employee does not have an address. Whenever you're dealing with objects, this is something that can occur. We need to make sure that we account for that. So let's fix the program so that if the address is null, we just print out a message and we don't cause the program to abort. I'm going to go into the employee class. In the employee class, this is where I actually set the address. But here's the problem. when I go to print the employee, I'm trying to print the address information, but sometimes there might not be an address. So let's add some code to the print employee method that will check for that. Let's say if the address is equal to equals null. Null is a keyword, so if the address has not been instantiated, then what I'll do is I'll print out all the information except for the address. So I'm going to come in and remove the address.toString, and I'll put a little statement in here that just says, no address is on file for this employee. That way it won't look like this is just a mistake. Okay, and I'll still print out the salary. Now, if there is an address, I want to go back and print it out the way I had it before. So I'll copy all of this, come down here to the else, paste it. Okay, line everything up. And this time I'll go ahead and put my address back in. So I want to do address, and I'll do a plus sign and say address.toString, and plus again. Okay, so if the address object is null, then I'm going to go ahead and print out the employee without an address. If the address is valid, I'll print it out. Let's see if this helps. Let's go back to our payroll program, and let's run this again. Well, we didn't get any stack trace errors. That's a good sign. Let's start from the top. We have Peggy Fisher, lecturer, with her address. Then we have Bob Fisher. And then we have Jane Smith, who's an administrator. And notice it says no address is on file for this employee. It still has her employee ID, her department, and her salary. I hope this helped you to understand what it means when an object is pointing to null. It means that it hasn't been instantiated yet. And it's a good idea to make sure you test for a null value and prevent encountering a null pointer exception like we did the first time. It's time for the challenge on classes. In this challenge, we've been hired by Kathy's Catering. Kathy's Catering has hired us to create an application to help manage her upcoming events. The catering company provides meals for parties and special occasions, such as weddings, birthdays, bridal showers, baby showers, those types of events. So for this challenge, I want you to create an event class. The event class will hold specific information about the event, the type of event. Make this a string variable so we can hold things like wedding, retirement, birthday, the date of the event, the number of guests. Let's set a default cost for each guest to $40 inside of the class. And finally, I'd like a computer-generated event number. This number will start with the first letter of the event. So for example, if it was a wedding, it would start with W. Define a static variable for the next number. That way, it'll automatically add 1 to our number regardless of whether the new event is a wedding or a birthday or a shower. Now that we have all the instance data defined, let's talk about the constructors needed for the event class. Let's add at least 3 constructors. One will be used when only the event name is known. The second constructor will have the event name and the date of the event. And the third constructor will have the event name, the date, and the number of guests. In addition to the constructors, we're going to need accessor and mutator methods for each piece of instance data in our event class. So go ahead and add set and get methods for all the instance data. We also need to have a method that will calculate the total for this event. We want to take the number of guests times our price per guest and return that value to the calling method. And finally, let's add a print method so we can print out all the information about the event. Okay, that's it for our class. Now let's get back over to the main program. In the Java file that contains the main method, we want to add helper methods to get all the event information. In the main method itself, we're only going to have 2 statements. One to create an event object, and a second one to print out the information about the event. The helper methods will be used to prompt the user to enter the information about the event, the type of event, the number of guests, and the date of the event. Okay, now you have all the information you need to get started. So give this challenge a try. I'm estimating that this should take about 30 minutes. You might be able to get it done sooner, especially if you've already written some classes on your own. But either way, Go ahead and give it a try and have some fun. Good luck! So how did you make out with the Kathy's Catering Challenge? I hope you had some fun with it. I'd like to show you my solution, and as I always say, it might be different than yours. Let's start with the event class. At the top of the event class, we have our instance data. On line 10 is something a little bit new though. I have public static int next event number. By declaring this variable as static, it allows all the events that I create to share the same value. Normally, the instance data is only available to the one object, but when you add the word static, it allows the variable to be shared. An example might be, what if we wanted to count up the number of events that we have coming up? By declaring a variable as static, we can add one to it every time we create a new event. It's not specific to a certain event, it's specific to the entire collection of events. On line 14, notice that we have private final double price per guest. That way, if the price changes, it's easy for us to change it in one place. I mentioned in the challenge that I wanted you to create 3 constructors. Let's take a look at those now. The first constructor only takes in a string of type. It sets the event type to that type, it sets the number of guests to 0, and the event date to null, because at this point we don't know the number of guests or the event date. And then I set the event number. The second constructor takes in 2 values, the type of event and the event date. And finally, the third constructor takes in 3 values. If the user knows the type of event, the event date, and the number of guests, we can use that information to create our event object. Starting on line 38, you'll see the accessor and mutator methods. You might want to take a look at the method starting on line 42. This method is creating the event number. It uses the first letter of the event type and then adds the next event number. Every time I create a new event number, I need to add 1 for the next event. Finally, I'll scroll down to the getTotal method on line 70, and again, this returns the guest times the price per guest. And at the very end, we have our method that will actually print out the information about the event. The last method is the print event method. This method prints all the information about the event. Okay, let's go back to the main program, Kathy's Catering. You can see in the main method, I only have 2 calls to 2 methods. Event equals getEvent. That is creating the new event. And then I have event.printvent, and that will call the print event. If I scroll down, you'll see the helper methods. On line 20, I have getEventInfo. This method returns an event object. It also uses the helper methods to get the event type, get the number of guests, the date of the event, and finally creates a new event to be returned back to the main method. On line 28, I have my getNumGuests method. It returns an integer with the number of guests. On line 41, we have our getEventType. In this method, I actually use a do-while method because I wanted to give the user a menu of choices. In the loop, we ask the user what type of event they're hosting. And finally, the last method is used to get the date of the event. Let's run the program so you can see how it works. I added some error logic in case they type something other than 1, 2, 3, or 4. Remember, it's easy for an accident to happen, so you want to try and make sure you think about those types of things ahead of time. Invalid selection, please try again. Let's say it's a birthday. I'm going to click 2. And for this birthday, I expect 30 guests. The date of the event is going to be this summer, and it's going to be July 4th, 07/04/2015. I'm going to hit Enter. My event is for a birthday, and you can see it assigned an event number B100. It's scheduled for July 4th, 2015. I'm expecting 30 guests, and the cost of my party will be $1,200. Okay, I hope this solution made sense to you. Take some time to go through and take a look at the differences between how you approached the challenge and how I approached the challenge. In this challenge, I only created 1 event in my main program. Go ahead and add some more events and print them out and check out the event numbers. You might even want to try creating an array or an array list of events to allow the program to schedule many events at one time. This is my solution, and I hope you really enjoyed this challenge. When working with classes, you'll hear the word inheritance. So what is inherited? Inheritance provides a powerful and natural mechanism for organizing and structuring your software. This section explains how classes inherit both state and behavior from their superclasses and explains how to derive one class from another using the simple syntax provided by the Java programming language. Inheritance allows one class to be created based on the definition of another class. The new class inherits all the instance data and methods from the base class, thus reducing data redundancy. There are numerous real-life examples of this concept. For example, we might identify a shape class, which describes a wide range of shapes. For example, circles, rectangles, and triangles are all shapes. They all have some common characteristics, but then each one has additional features specific to that shape. For example, to calculate the area of a circle, you need to know the radius, pi r squared. To find the area of a rectangle, you need the length and the width. To find the area of a triangle, you need the base and the height. When these relationships exist, we can say that a circle is a shape, that a rectangle is a shape, and that a triangle is a shape. The key here is the two words is a. This means that the specialized class has all the characteristics of the general class. It also has additional characteristics that make it unique. For example, as I said earlier, a circle has a radius, rectangle and triangle do not. But all three of these things are shapes. One of the biggest benefits of inheritance is that we can define one base class and then extend that to other classes that inherit these characteristics plus more. It reduces the amount of coding we need to do. When we use inheritance, we use keywords extends and implements. One object acquires the properties of another object. Let's take a look at an example. I have a project here called Geometry. And in the Geometry project, I have 5 Java files. I have a main Java file that's geometry.java. I also have a shape file, a rectangle file, a circle file, and a triangle file. Let's take a look at the shape file first, since that is the superclass. I made this class abstract because I wanted to make sure that any classes that inherit from the shape class define their own method for calculating the area. We'll talk a little later about abstract classes, but this seemed like a good place to have an example. The two pieces of data that all shapes have is a name and an area. So I added private string shape name and private double area. Then I have 3 different constructors. I have a shape constructor that doesn't take any parameters and just sets the name to shape and the area to 0. I have another constructor that takes in just a name and assigns the name from the calling program to the object, this.shapename, and sets the area to 0. And finally, if the user provided the name and area, I'll set both of those values. Let me scroll down a little bit, and you'll see the reason this is an abstract class is because I have public abstract double calculate area. Notice that there's no code inside the calculate area method. That's how abstract methods work. But it does require that if any classes extend the shape class, they have to implement calculate area. Let's see what I mean. Let's look at the circle class. On line 8, public class circle extends shape. That means it inherits all the values that are in the shape class. I have a constructor here as well, and if you don't provide any value, it will automatically call the shape constructor and give it the shape name of circle. I also added a constructor to allow the user to specify the name of the shape. So maybe they want to put coin or orange or ball or something like that. And finally, you can see I have public double calculate area. This is unique to the circle because the circle uses the formula pi r squared. Let's look at the rectangle. The rectangle also extends shape, and the only difference here is the way it calculates the area. It reads in the length and the width and returns length times width. And finally, the triangle. Again, the triangle extends the shape class, but in order to calculate the area of the triangle, I need the height and the base, and I return 1/2 times height times base. Okay, in the main program, I've just set it up to create one instance of each of the classes. So I have shape coin is equal to a new circle, and I gave it a name of coin. And then I print out the area. Then I have shape square is equal to a new rectangle. And finally, shape triangle is equal to a new triangle. Let's run the program and see what happens. The first thing I have to do is enter the radius of my circle, and I'll use 100. It's nice and easy. And you can see that it automatically takes 100 squared times pi. Now I'm going to enter the length and the width of my rectangle, so we'll make it a square. We'll make it 25 by 25. The area is 625. And finally, I'm going to enter the height and base of my triangle. So I'll just enter 50 and 10. And the area of the pyramid, which was the name that I gave my triangle, is 250. As I stated earlier, inheritance is one of the key aspects of object-oriented programming, and it really does allow for reduced coding. My example was quite small, but it's a very powerful tool, and we'll use it a little bit more in future sections. The next topic I want to talk about is interfaces. An interface is like a contract between a class and the outside world. When a class implements an interface, it promises to provide the behavior included by that interface. Interfaces can also be used to store constants. This section defines a simple interface and explains the necessary changes for any class that implements it. As you've already learned, objects define their interaction with the outside world through the public methods used to get and set information. Methods form the object's interface with the outside world. The keys on your keyboard, for example, are the interface between you and the electrical wiring on the other side of its casing, which connects it to the computer. Also, the power button. When you press the power button on your computer, it turns the computer on or off. It's an interface. Most interfaces are a group of related methods with empty bodies. Let's use a bicycle as an example. A bicycle's behavior, if it's specified as an interface, might appear as follows. Public interface bicycle. It contains 4 methods. Void change pedal rate, void change gear, void speed up, and void apply brakes. To implement this interface, we could create a class called mountain bike, which I have here. On line 12, we see that the public class mountain bike implements the interface bicycle. Because of that, if I scroll down, you'll see I had to actually provide code for all 4 of the methods that we saw earlier: change pedal rate, change gear, speed up, and apply brakes. I've also added a void method that will print these states. It's important to note that if you did not implement each of these methods, the compiler would fail and give you an error message. You cannot implement an interface without implementing all the methods that are included in the interface. Let's take a look at the main method, the interface demo. As you can see, I have mountain bike Huffy equals new mountain bike. Huffy.print states, I'll print out the states of the mountain bike prior to making any changes. Then I'm going to call the change pedal rate, the speed up, and the change gear, and print the information out again. Let me just show you how this would work. In the output window, I can see that the pedal rate is 0, the speed is 0, and the gear is 1. Those are the default values from the bicycle interface. After I update the values and print it out again, the pedal rate is now 2, the speed is now 5, and the gear is now 1. Implementing an interface ensures that the class provides all the required behaviors associated with that type of object. As I stated earlier, interfaces form a contract between the class and the outside world. And this contract is enforced at build time by the compiler when you add the implements keyword. If your class claims to implement an interface, all methods defined by that interface must appear in its source code before the class will successfully compile. The interface body can contain abstract methods, default methods, and static methods. An abstract method within an interface only contains the method header followed by the semicolon. A default Public static final int north is equal to 0. We have east equal to 90, south equal to 180, and west equal to 270. Now we can use these values in our calling program that implements the bicycle interface to determine the rider's direction. This allows us to use the words north, east, south, and west without worrying about remembering the numeric counterparts. An important interface that's available in the Java API is the comparable interface. When we are working with classes and objects, we often want to compare a list of objects, possibly for sorting or to check to see if two objects are the same. So the question is, how to compare objects? What defines a comparison of any two objects? Or what defines the comparison of two address objects? Maybe an address includes the house number, the street name, the city, the state, and the zip code, or maybe something else. What value should we use? Do we compare by street name, by zip code? That is where the comparable interface comes in handy. By implementing the comparable interface in our class, we're required to provide a compare_to method that returns either a positive number if the calling object comes before the other object, 0 if the two objects are equal, and a negative value if the first object comes before the second object. Again, in order for this to work, you must first have an idea of what does it mean comes before or comes after. Let's look at the address class in our payroll application. It is currently set up to compare addresses using zip code. So here is our address class, and as you can see, it implements comparable on line 7. Since I implemented comparable, if I scroll down, you'll see that I actually have a compare_to method defined. And on line 50, it even says @override. That's required if you're going to use the comparable interface. Then I have public int compare_to. In the parentheses, it says object A, because the comparable interface and the compare_to method allow any object to be compared. So inside of my method, I actually have to determine what type of object that is. So the first line of code on line 54, you can see I'm actually casting the object that came in from the calling program, object A, as an address object. So I create a new address variable, addr, equals, parentheses, the type of object it is, which is an address, close parentheses, and an A. On line 55, I'm converting the zip code of the calling object to an integer value. Line 56, I'm taking the other object, the addr object, and converting that string zip code to an integer zip code. Now I can compare them. Line 57 says if zip code of the calling object is less than the zip code of the object that was passed as a parameter, then I return a -1. Otherwise, if zip code 1 was greater than zip code 2, I return a positive value. And finally, if they're the same, I return 0. So when you want to compare objects, make sure you implement comparable. You will need to decide ahead of time what constitutes a comparison of your particular classes and objects. Let's move on to polymorphism. The question is, what is it? It is an odd term, but it's actually very powerful when you're dealing with classes and objects. First, let's talk about what it is. So when we use inheritance to create new classes, each new class inherits both the data members and the methods of the superclass. But sometimes the methods need to behave differently depending on the new class definition. In the case where the subclasses may need to behave differently, they still contain the same method name, but they have a different implementation. Okay, all that's well and good, but let's talk about a real-life example. We're all familiar with animals. So if we have an animal class, and we define 3 types of animals, and we use animal as our superclass, and we inherit to create the subclasses dog, cat, and pig. They're all animals, but when a dog speaks, it barks. But when a cat speaks, it meows. And finally, when a pig speaks, it oinks. So the animal class would have a quote-unquote generic speak method defined, but each of the inherited classes would redefine this method with their specific types of speak methods. So the thing that you want to remember about polymorphism is that it allows you to have the same name for a method, but it acts differently based on the class that has that method defined. Another example might be if you had a bug class, and the bug class created subclasses of grasshopper. A grasshopper, when it moves, it hops. Maybe a ladybug, when it moves, it flies. So polymorphism is saying that it has the same method name, speak or move, but the actions that are performed are dependent on the class. And in the example I have here, it's dependent on whether or not the object was defined as a dog or a cat or a pig. For more detailed information and examples of polymorphism, please visit Foundations of Programming, Object-Oriented Design with Simon Allardyce, specifically the video titled, What is Polymorphism? Moving on to abstract classes. When defining an abstract class, you must include the keyword abstract in the class header, such as public abstract class shape. The class may or may not include abstract methods. It's important to understand you cannot instantiate an object that is of the type of the abstract class. Although abstract classes cannot be instantiated, they can have subclasses, and any abstract methods inside the abstract class are declared without an implementation in only the method header. So what happens when a class inherits from an abstract class? The subclass must provide the implementation for all the abstract methods that are in the parent class. If it does not, it must be declared as abstract also. Abstract classes are similar to interfaces. Once again, you cannot instantiate an interface, and an interface may contain a mix of methods that are with or without code. When we worked with the geometry class earlier and we had a shape class, it was an abstract class. Let's go back to that. Here's the shape class. On line 10, you can see it says public abstract class shape. And there are some data values specified there and some constructors. And if I scroll down, you'll see there's an abstract method also, public abstract double calculate area, but it has no code defined for this method. But any subclass that inherits this method must implement the code. Well, that makes sense because shapes come in all different shapes and sizes. For example, to calculate the area of a circle is much different than calculating the area of a rectangle or a triangle. So if I want to create an object that uses the shape class, if I go to my main method, I can do that, but I have to instantiate it using one of the subclasses, circle or rectangle. Let me show you what happens if I try and create a shape object. We'll just call it shape1, and I try to instantiate it as a new shape object. Intuitively, you think that would make sense, but you can see if I mouse over the error, it says that the shape class is abstract and cannot be instantiated. The code on line 13 shows how we can instantiate a circle. Shape frisbee equals new circle. And on line 15, we have a square is equal to a new rectangle. So now you're probably thinking, well, when do I use an interface and when do I use an abstract class? Use an abstract class if you want to share the code. You expect to have common methods or fields. If you require access modifiers other than public, such as protected or private, or if you want to declare non-static or non-final fields. This enables you to define methods that can access and modify the state and behavior to which they belong. You want to use an interface if you expect that unrelated classes would implement your interface. For example, the interfaces comparable and clonable are implemented by many unrelated classes. You would use an interface if you want to specify the behavior of a particular data type, but you're not concerned with who implements its behavior. And finally, use an interface if you want to take advantage of the multiple inheritances. You can only extend one class, but you can implement one or many interfaces. Are you ready for the next challenge? In this challenge, I've tried to include several of the concepts we reviewed in this section. We've been contacted by a friend who owns a pizza shop. She wants an application that supports online ordering. After talking to the owner, we decided to create the following: a pizza class that implements the comparable interface. Again, this is for a pizza shop, and this particular pizza shop offers two types of pizza, regular and Sicilian. The regular is circular, but the Sicilian is formed in the shape of a rectangle. So we will have a superclass for pizza with two subclasses, regular and Sicilian. The comparison will be used to sort the pizzas based on size, small, medium, large, and extra large. The pizza class needs to include the size of the pizza, the type of pizza, toppings. Will include an array list of strings to allow for multiple toppings, and the cost of the pizza. The main program will ask the user for the customer name, the type and size of the pizza they would like to order, the number of toppings. We're going to allow up to 4 toppings for a regular pizza, but only 2 for Sicilian. Finally, we'll print out the total for the order, including a description of the pizza they ordered. It would be nice to allow the user to enter multiple pizza orders at one time. Try that for a little extra challenge. I'm estimating that this activity might take about 30 minutes, so don't be discouraged if it takes you a little while. I hope you liked that last challenge. What I'd like to do is take a look at my solution, but again, remember that your solution might be very different. I'm going to try and point out some of the key aspects that I chose for this program. Let's start with the pizza class. Remember, this is the superclass because there's 2 types of pizza, regular and Sicilian, that will extend the pizza class. So at the top, I have public abstract class pizza implements comparable. We knew we wanted to be able to compare 2 pizzas based on their size. Next, I have some constant variables that show how big a pizza is. A small diameter is 12-inch, medium is 14, large is 16, and extra large is 18. I have a price array that includes the cost for each of those pizzas respectively. Let's scroll down a little bit, and you'll see I have some constructors for the pizza class. What I want to show you is on line 40, I have public abstract void get toppings. Can you think of a reason why I'd want to make that an abstract method? If you remember, one of the differences between the Sicilian and the regular is that the Sicilian only allows for 2 toppings, where the regular pizza allows for up to 4. So I wanted that logic to be different if they were choosing a regular pizza versus a Sicilian pizza. And my compare to just checks the size of the pizza. Okay, let's take a look at the regular class. So this is for our regular pizza. If I scroll down, I have a method that returns the cost. And you can see here's where I override the get toppings. Remember, this was abstract in the pizza class, so I have to provide the implementation here. You can see it asks the user how many toppings they want. If they try to order more than 4, it's going to give them a message saying, sorry, you're limited to 4, and ask them how many they want. Once I know how many they want, I'm going to scroll through and ask them to enter the name of the topping. Okay, let's look at the Sicilian class. This class also has a get toppings method that is overriding the one that's in the pizza class. So on line 27, it says @override. This time, I check and see on line 33 if the number of toppings they chose is more than 2. Again, I give them a message saying you're limited to 2, how many toppings would you like, and then I read in the value for the toppings. Finally, let's take a look at the main class, the pizza shop. In the pizza shop class, I'm going to scroll down a little bit. I ask for the customer name. I ask what type of pizza they would like. I ask what size they would like. Based on that, I create the right pizza, whether it's a regular or a Sicilian. And finally, I get the toppings and print out the total cost. Let me run this so you can see how it works. So I'll put in the customer name, Ray Johnson, and this person would like a regular pizza. They would like a large with, let's try 5 toppings. Remember, you're only allowed 4, but it's always good to test to make sure your logic works. Sorry, you're limited to 4. How many toppings would you like? Well, I'm going to jump it down to 2. And I know that Ray likes pepperoni, and I think we'll get some extra cheese this time. And out comes the message, your pizza has been ordered with pepperoni, extra cheese, and the total cost is $18. Take your time to go through each of the classes that I have defined here in the Pizza Shop package. And remember that your solution is probably going to be different because everybody programs slightly differently. I hope you had fun with this, and don't forget the extra challenge of trying to allow for multiple pizza orders at one time. At this point, you're probably already familiar with arrays, but let's go over some of the basics. An array is a container object that holds a fixed number of values of a single data type. The length of an array is established when the array is created. Once the array is created, the length cannot be changed. To reference elements in an array, we use an index value. That index value represents the location of the element in the array. The index values always start at 0 and go to length minus 1. So if you have 10 elements, the first element is always going to be in position 0, and if there's 10, the last one will be in position 9, because you have 9 places plus the position 0 makes 10. The values in the array are stored in consecutive memory locations. The syntax for an array includes the data type and 2 square brackets equals a new data type, a square bracket with the size, and a closed square bracket. Or you can specify an initial list of values to be included in the array, and the size will be calculated automatically. There is one caution: beware of the out-of-bounds error. Since arrays are a fixed size, if you try to access data at an index value greater than the size of the array, your program will end abruptly during execution. This is not checked ahead of time by the compiler. But remember our section on error handling, and it might be helpful to add a try and catch for an index out-of-bounds error. Arrays can contain any of the primitive data types. Let's take a look at some examples. I have a class called Array Examples, and inside my class I just created a few sample arrays just to review. The first one on line 13 is an integer array. I start by declaring the data type int, and then I have an open square bracket and a closed square bracket. The name of my array, in this case I just called it ages, is equal to a new int array with 20 values. Remember that an array is a container object, and just like when we created classes and objects, we had to instantiate our objects by using the keyword new, the same thing applies to arrays. So when you're creating a new array, such as int ages equals, you have to say new int. When you declare an array and you give it a list of values, you don't have to use the keyword new. So on line 14, I have a double array with my square brackets called prices, and it contains 4 values: 5.25, 6.50, 2.30, and 10.75. The length of that array would be 4. But remember, the array index value starts at 0 and goes to 1 less than the length. So starting on line 16, I wanted to add the values together. So I have double total equals prices at position 0 plus prices at position 1, prices at position 2, and finally prices at position 3. If I tried to access prices at position 4, I would get an array index out of bounds error. The next array is actually a Boolean array. You can create an array that holds a list of values that are either true or false. I named this array responses, and I just set it equal to true, false, false, true, true. We can also have character arrays. For example, it might be handy to have an array that includes all the vowels. So I have character, bracket, bracket, vowels equals, open curly bracket, A, E, I, O, and U. Note there's single quotes around each vowel because this is a character array, not a string array. And the last array is an example. If you wanted to have an array that can hold 10 names, you might declare string bracket bracket names equals new string bracket 10 bracket, semicolon. This program contains a few of the examples of the types of arrays that you might want to create. Now that we've done a quick review of arrays, let's talk about the Arrays API that's included in the Java JDK. The Arrays API can be used if you include the java.util.arrays at the top of your program. It contains many useful array methods. Some of the methods include search methods, comparison methods, fill methods, copy methods, and sort methods. Let's take a look at a program that uses some of these. I have a program called Sample APIs. On line 14, 15, 16, and 17, I declare a few arrays. One's an integer array called numbers that just has some random numbers. Then I have a character array that lists all the vowels. Notice, since it's a character array, the vowels all have single quotes around them. And then I have two Boolean arrays that contains some Boolean values such as true, false, false, true, true. I know in many programming problems you have to try and find a value in an array. You want to search for it. A pretty efficient search is called the binary search, but a binary search requires that the array is already in sorted order. But lucky for us, one of the static methods in the Arrays API is a sort method. So on line 19, I print out the array numbers prior to sorting. Then on line 20, I use the sort method to sort the numbers array. Notice the way that I had to set this up. Since the method is a static method, the first thing I have to do is specify the class name. The class is called arrays.sort, and then in parentheses, I give it the variable for the array that I want to sort. So I'm sorting numbers, and then I'm going to print them back out again. This sort method works with arrays of type int, double, character, byte, long, short, and even objects. The next thing I wanted to show you in my program is how to use that sorted array and perform a binary search. A binary search is used to find a specific value in an array. So you need to first identify what is the value you're looking for. On line 25, I have int key equals 25. On line 26, I'm going to use the static method binary search to look for that key in my numbers array. So I have int key position because the binary search method returns the integer value of the location of the key that I'm looking for. So I have int key position equals arrays, the class name, dot binary search. In parentheses, I give it the numbers array and the key value that I'm looking for. This binary search works with arrays of types int, double, character, byte, long, short, and object. But remember, a binary search only works if the array is already sorted. On line 28, I print out where the key was found in the array. On line 30, I wanted to show you how to use the static method equals. This method allows us to compare any two arrays to see if they are equal. So I have if arrays.equals, and in parentheses, I give it the two arrays. In this case, I'm going to pass the two Boolean arrays that I created. Notice that the values are not the same. Each array has all the same values, but they're not in the same order. So on line 30, we're going to use the equals method to compare those two arrays. If they're equal, then it'll print out a message saying they are the same. Otherwise, it'll print out they are different. And the very last method I wanted to show you was how to use the copy of method. If I wanted to make a copy of the numbers array and maybe double the size, because arrays are a static size, I can create a second array called numbers2. So on line 36, I have int bracket bracket numbers2 equals arrays.copyOf. I give it the array that I want to copy, numbers, and I give it the length of the new array. So I went ahead and took the length of the first array, numbers.length, times 2. So that will actually give me an array that is 2 times the size of my original array. Okay, let's run this program to see what's happening. You can see before the sorting method is called, the numbers are out of order. After we called the sorting method, they're in order, and then my key was found in position 5. So let's count. The value 3 is in position 0. Remember, all arrays start with 0. The value 4 is in 1, 5 is in 2, 12 is in position 3, 17 would be in position 4, and 25 is in position 5. Awesome. Well, that sure made my life a lot easier, being able to use that binary search. And the last thing is the two Boolean arrays are different, and that's because the second Boolean array has the first two values reversed. It has false true instead of true false. Make sure you take some time to look at the Arrays API. I think you'll find that a lot of those methods will really come in handy. So far, we've only reviewed one-dimensional arrays, but it is possible to have a multi-dimensional array. Here is an example of an array called rents that has 4 rows and 3 columns. The array is initialized with values for 3 months, January, February, and March. Let's look at the syntax for a multi-dimensional array. On line 14, you see we have the data type int with 2 sets of square brackets. That's because this array has 2 dimensions. The name of it is rents, and it's equal to, I started out with some values. Notice I use an open curly bracket, And then I have a second open curly bracket that includes the first 3 values for the first row, and then a closed curly bracket and a comma. I'm still inside of my initializer list at this point. Line 15 represents row 2, where I have 3 more values enclosed in curly brackets. Line 16 is row 3, and line 17 is row 4. Line 18 I'm using to print out the titles of each of the columns, January, February, March. Then I'm using a nested for loop to be able to print out the rents. The outer for loop starts by specifying the row at position 0, and it goes as long as row is less than the array name rents.length, row plus plus. So this will go from 0 to 3, since there's 4 rows in my array. The inner for loop has int column equals 0, column is less than rents bracket 0 bracket dot length. Since the inner for loop represents the number of items inside the row or the columns, I have to specify the first element in the column rents bracket 0 bracket dot length to get the length of the columns. Then I'm printing out the rents at the row and column position. Let's run this and see what it looks like. You can see that it printed out under January the first column of values, 400, 500, 475, 625. Then February and then March. In this example, I wanted to show you that you don't always have to have the same number of rows and columns. In this example, I had 4 rows and 3 columns. And you can get at the length for each one by using the array name.length and then the array name for the first row.length. If you've ever worked with an Excel spreadsheet, a 2D array is very similar. In Excel, the columns are labeled A, B, C, D, etc., and the rows are numbered 1, 2, 3, 4. So each cell is referenced by combining the row and column, such as A1. In Java, we use the index position to reference each cell. So instead of A1, we will have bracket 0, bracket, bracket 0, bracket. The last type of arrays that we're going to talk about is an array list. There are several important differences between an array list and an array. An array list can only hold objects, such as strings. When using an array list, you can increase and decrease the size dynamically. To access the elements in an array list, we use the .get method, and to update elements in an array list, we use the .set method. If we want to add an element, we just use the .add element. We don't have to worry about the size of the array list. It'll automatically grow as we need it to. And if you want to take away an element or delete an element, you can use the .remove method. Remember our pizza shop? We mentioned that it might be nice to keep track of more than one pizza at a time. So let's see what happens when we use an array list to hold our pizza objects. Here's the main program for the pizza shop. At the top, I've already gone ahead and imported the java.util.arraylist. I'm going to scroll down a little bit. What we'll do is we'll add a while loop that will allow the customer to keep entering additional pizzas. When we're all done, we'll print out the array list. On line 19, I need to create my array list. And the syntax is array list, angle bracket, and then the type of data that you want to hold in the array list. In this case, I want to hold a pizza object. And we need to give it a name. I'll just call it pizzas is equal to a new array list. Again, I'm going to specify the data type of pizza. And I'm going to put an open and close parentheses at the end and a semicolon. So we've instantiated our new array list. It's ready to go. All we have to do is add some items. So let's add a while loop that will allow the user to keep entering pizzas. So we'll start by adding a string variable called response. And I'll set that equal to yes to start. And I'll say while the response dot equals. Remember, you cannot use equals equals when you want to compare two strings. So while it's equal to yes, I will go ahead and ask the user what type of pizza they want. I'll create the pizza object. So I'm going to scroll down to where I actually create the pizza object after I add the toppings. I want to add this pizza to my array list. So pizzas.add pizza 1. And that's going to add the pizza if it's a regular pizza. I want to go down to the second part of the if statement and also add it if it's a Sicilian pizza. Okay, the last thing I want to do inside of this while loop is I want to ask the user if they want to order another pizza. So I'll say, do you want to order another pizza? And I'll give them a hint. I'll do y/n so they kind of have an idea of what I'm looking for. And I'll read that value in. Response equals in dot next line. Okay, what'll happen is it'll come back up to the top, and if they enter yes, it'll go ahead and get another pizza. If they enter no, it'll get out of my while loop. Okay, now outside my while loop, it'd be nice to be able to print out the entire order. So let's go ahead and add a for loop. So I'll do for int I equals 0, semicolon, as long as I is less than pizzas, which is the name of my array list, dot. Notice it's not dot length anymore. Now it's dot size. Semicolon, I plus plus. And inside the for loop, I will print out pizzas dot get, and I'll get the value at position I. And then I'll do dot print string. That'll print out each one of the pizzas. Okay, once all of the pizzas are entered and the customer typed no for they don't want any more pizzas, I want to print out the pizzas they ordered. So I have a for loop that loops through all the pizzas in the array list, and then it prints out pizzas.getI.printString. Okay, let's try our program. And the customer name is Jim. He would like to start with a regular pizza, and he wants a small with 1 topping, extra cheese. Who doesn't like extra cheese? Okay, now the question is, do you want to order another pizza? Let's say yes. Okay, now I'm going to order a Sicilian to go along with the regular pizza. And let's get a large this time. And we'll do 3 toppings. I forgot, I'm only allowed 2. So let's do 2 toppings. Okay, we'll do pepperoni and let's do onions. This time I'm going to say no, that I don't want to order any more pizzas. And at the bottom, it says your pizza order with extra cheese is $12, and your pizza order with pepperoni, onions, and the total is $17. So it looks like I was able to add multiple pizza items to my array list. When trying to decide whether to use an array or an array list, consider the type of data you need to keep track of. If it is susceptible to change, you might want to use an array list. The big benefit of array list is that you can increase and decrease the size dynamically. But keep in mind that although array lists seem like the answer to all of our array limitations, it comes at a price. Array lists require additional processing time and can use more space than an array. The last topic in this section is called the enhanced for loop. The enhanced for loop works really well with both arrays and array lists. After creating an array, you can easily traverse the array using the enhanced for loop. The syntax is a little strange at first, but it reduces the coding needed to go through the entire array. Some quick notes about the enhanced for loop: it can only be used when you want to start at the first element of the array and go through all the way to the end. And another note is that you cannot have any code in the loop that alters the contents of the array. You can kind of think of it as a loop that will allow you to read the elements in an array or an array list. I want to show you how to use the enhanced for loop with both a regular array and an array list. I'm going to go back to my array examples, and I'm going to show you how we could use an enhanced for loop for a couple of these arrays. I'll put this at the bottom. So an enhanced for loop looks like this. It has the word for, and then you declare the type of objects that are in your array. So let's go with the prices array first. So the type is double. I need to give each element in the array a temporary name, so I'm just going to call it element. Then I put a colon, and now I specify the name of the array that I would like to go through and traverse. So I'm going to put prices. Inside of my for loop now, I can go ahead and print out each element in the array. So I can say element, and we'll print each element on a separate line. That's it. I don't need to keep track of a counter. I don't need to figure out how big it is. Using the enhanced for loop, it knows when to stop when the array is done. Let's add another enhanced for loop that will actually go through my Boolean responses. So again, you type in the word for, you put your data type, so we'll put Boolean, and we'll call it response this time. This variable name can be anything you want, and it holds the value of each element one at a time, just temporarily until it gets to the next element. The name of the array that I would like to traverse is responses. And I'm just going to do the same thing. I'm just going to print out the value response each time through. I'm going to scroll down a little bit. Okay, let's run this just to see how it works. If I make this window a little bigger, we'll see that it printed out all the elements in my prices array, starting with 5.25 and ending with 10.75. Then it went on to print out all the values in my responses array. True, false, false, true, true. So remember, you can go through all the elements easily, but you cannot change any of the values. Let's take a look at our pizza shop, which I also have open, and I want to show you how we can use the enhanced for loop to print out the pizzas. So I'm going to go over to Pizza Shop. At the bottom here, I have the for loop from our last activity. For int I equals 0, I is less than pizzas.size, I++, and then we printed out pizzas.getI.printString. Let's change this to enhanced for loop, and you'll see how much simpler it is. I'm going to say for the type of data that I'm going to be traversing in this array list is pizza objects. So I type pizza, we'll call it P, colon, and the name of the array list is pizzas. And down here inside the loop, I just use the variable name that holds each object one at a time, which is just P. I'm going to do P.printString. That's it. Now that will go through and it will actually print out each pizza in the list of pizzas. So let's try this one as well. We'll use a different customer. Let's say Jane came in this time. And Jane would like to start with a regular pizza, a size large, one topping, and she'll have pepperoni. And I'm going to say yes, she wants to order another one. She's going to order a second regular pizza. This time she's going to get an extra large, and she'll put 3 toppings on it. We'll do pepperoni. This will be a meat one. Sausage. How about if we just go with peppers? Okay, that's 2. Let's add one more. This time let's do a Sicilian. And this will be a small, and we'll do 1 topping. And this can be cheese. And I'll say no. You can see that the enhanced for loop printed out my pizzas. My pizza order with pepperoni has a cost of $16. The pizza with pepperoni, sausage, and peppers is $22. And the pizza with cheese is $2.50. That's a very inexpensive pizza. I think I have some debugging to do there. Okay, so remember that if you just want to go through the entire array or array list and not worry about updating any of the values, you can use the enhanced for loop. Give it a try. I think you'll really like it. It's time for another challenge. In this challenge, I would like you to write a complete Java program that includes a separate method used to find a specific name in a 2-dimensional table. We'll call this the name search game. In the exercise folder, you will find the start of a program including a main method that contains a 2D array of names. Your job is to write the method that takes 2 parameters, a 2-dimensional array of strings called nameTable and a string called nameToFind. The method returns a Boolean value of true or false. Your method should search the 2-dimensional array of names to check for a match with nameToFind. Your program will ask the user to guess a name. You'll use the method to search the array and print out a message if the name was found. Make sure you allow the user to play the game more than once. But before you actually turn this over to someone, make sure you test it using a valid value that is found and a value that's not found. I've estimated about 15 minutes for this activity. Have fun with the name game. So how did you make out with the challenge? How is your name game working? Let's take a look at my solution, and as always, remember that your solution might be very different. As you can see in the main method, I have the 2-dimensional array of names, and then I added some additional code. I wanted to allow the user to execute the program more than once, so I declared a string variable response and set it equal to y the first time. I also declare a string variable name that's going to hold the name the user would like to search for. My while loop says while response is equal to a y, ask the user to enter the name to search for. Then we'll read the name in using the name equals in.nextLine on line 32. Then I call my search name method, and I give it the two-dimensional array called names as well as the name that I'm trying to search for. If the value that comes back from the method is true, I print out the message saying the name was found. Otherwise, I print out the name was not found. Finally, I ask the user if they would like to try again. If they say yes, it'll go back to the top, and if they say no, it'll come down and say thanks for playing the name search game. Now let's take a look at the method. I hope you were able to figure out the method header, public static boolean. It's static because I'm including it inside the same program with my main, and boolean because it returns a true or false. The name of the method in my case is search name, and the arguments that I'm passing to it is a string array that contains two dimensions called names and another string called key. That's the value that I'm looking for. I have a nested for loop. The outside loop says for int row equals 0 as long as row is less than names.length, row plus plus. That allows me to change the size of my names array in the main method at any time without having to worry about changing the values down in the method. The inner for statement says for int column equals 0, column less than names at position 0 dot length, column plus plus. Again, this is nice because if I ever want to add a third column to my table, I can do that without changing my search name method. Then I check and say if names bracket row bracket bracket column bracket dot equals ignore case, the key, which is the name the user entered, then I can stop the method and just return true. Because once I find a match, I don't need to search anymore. If it's not equal, then I'll go back up to the inner loop and then back to the outer loop and go through the entire table. If I make it all the way through the entire table and I still haven't found a match, I'm going to execute line 52, which at the very end returns the value false. Okay, let me go ahead and play the name game so you can see how it works. I'll search for a name that I know exists. I'll put in Donald. The name was found. Would you like to try again? Let's say yes. Let's find a name that's not there. I'll enter Bob. The name was not found. And let's do one more that I know will be found. Let's look for Ray. The name was found. This time it says, would you like to try again? I'm going to say no. Thanks for playing the name search game. Well, I hope you had fun with this challenge. And if your solution is different than mine, again, don't worry, but make sure you take time to go through my solution to make sure you understand how to use a two-dimensional array and how to pass it to a method and return a Boolean value.